Something is hearing, or my microphone was off actually. A very good morning to all of you. Welcome to webinar series of Modern Trends in Transportation System. We hope you all are doing well and safe. Moving straight, let us start today's series by welcoming our speakers for the day. So today's first speaker is Dr. Abhijit Maji, the Associate Professor of IIT Bombay. He obtained his PhD from Morgan State University, USA, and Masters from IIT Kanpur. His interests are machine intelligence and computer vision in alignment development, optimization in transportation infrastructure, transportation safety and security, high-speed rail infrastructure planning, and innovative highway infrastructure design. He handles transportation subjects throughout the various levels. He authored over 10 book chapters, published in 30 research papers and 30 conference proceedings. He handles transportation subjects throughout all the different MTech and BTech levels. He has 15 years of professional and research experience. So now over to you, sir. You have 1 hour for speaking. Stage is yours.
Thank you, Ambika.
Thank you, sir.
So, yeah. So, good morning to all of you. I hope.
Very good morning, sir. You are visible and audible. Please continue.
Thank you so much. So, I was expecting that confirmation because online is totally virtual and we don't know who is on the other side and what they are seeing.
Yeah, correct,
So,
sir,
very good morning to all of you and welcome to this presentation. I first like to appreciate and thank NIT Silchar for organizing this webinar series. In this difficult time, basically when we are confined to our place, it is better to learn more, and this is the perfect opportunity to do so. We are there are few webinar series all over India and outside India as well. All are very informative, and to be honest, I learned a lot from all this webinar which I attended during the lockdown period. And another thing is which I couldn't actually attend, even though some of those were there earlier because of the busy schedule or some other activities which needed lots of travel. But this is the perfect example when without traveling, still we can communicate or provide, reach each other in a better way for the for good. So today I'm going to talk about the performance-based evaluation of two-lane undivided rural highways. And this presentation is going to cover some of the safety aspects which you might have heard yesterday from Dr. Velumurugan, and also some of the things which was there in the instrumented vehicle covered by Dr. Vinod Vasudevan. But here you will be seeing that certain applications which we actually did in our research in the last few years through the PhD students and the MTech student working under my guidance. So before I give the credit to them, that will come at the end. So first of all, we need to understand what is we are talking about, what is the performance, and why we are talking about the performance. So in this, basically what we are looking into a system. Whenever we look into the roadway, it's a system, and the roadway system, there are roadway environment, a vehicle is there, and as well as the driver is there. And these all three things work in sync. If there is any mismatch, if there is any issue in communication between the three, accident can happen. And if you look into the crash data or the history, basically more than 50% of the road crashes happen in the rural highways. So when we say rural highways, we are talking about the highways or the rural roads which are outside the limit of urban area, where you have less access to the roadway and the speed on the roadway is comparatively higher than the urban part. And of course, these are the highways which are meant for long distance travel. Now, in these accidents, if we see, try to understand what are the common errors, we'll find out that the driver error is the most common error, and it has been reported in MORTH 2016, even in the latest one as well, and even in the literature available outside of India, and this is quite common. Now, another thing which when we looked into, and we mostly know the police also reported in that way, and possibly that is the reason what our accident report or the crash reports indicate, is that most drivers exceed the lawful speed limit during the accident. And this is the reason why the accidents were happening. And this actually gives us a clue why they are exceeding, what is happening, because they are supposed to communicate with the road. Is the road is giving us a different information, or the driver is different? We'll try to explore these things through our work, which I'm going to present today. Then another thing, we are talking about the heterogeneous traffic in our Indian roadways, and where we see cars, trucks, buses, and other vehicle types, smaller two-wheelers. So when we look closely, like, okay, there are speeding issues. So who are speeding and which are the vehicle which are getting involved in the accident? We find that 45% of the cars have higher operating speed than the design speed. So we may associate them to be the vulnerable. So for this is just the background. I'll come to the reason why we are looking into this. Based on this, all these facts, we want to study the performance. So when we say about the performance, we need to understand, like, when we go to a store to buy a mobile device or any of the electronic device, the first thing we like to ask is it going to last? How long is going to last? What is the performance of this? What is the review of this? So if you are asking that for a product, why can't we look into our the roadway in the same way? And when we look into that, one of the things which comes to your mind is how can we look into the performance? One of the performance measure is safety, and Dr. Velumurugan had covered a lot or discussed a lot about the safety yesterday, and if you recall those things, you'll see the relevance why we are looking into that aspect. Now, what we are talking about this product, what it entails, what are the details? We are looking into the product, which is the roadway. And when we talk about the roadway, the product has certain specifications, which is one of them is the design speed. And based on the design speed, we develop the product which has horizontal alignment, vertical alignment, or vertical profile. And these two elements are developed based on the side distances which we want to design, and which the side distance is again constituted or considered from the design speed. And as we look into this, there is a third element in the design, which is the cross sections. Now, when we are designing all these things and looking into the safety, and when we are looking into the performance, we definitely need to understand the side distance, and particularly, as I said, two-lane highway are critical. So the side distance, one of the side distance which is critical for the two-lane highways is the overtaking side distance. So in this presentation, again, we'll be focusing on that. So the main focus of this presentation, one of this is the horizontal alignment, even though the vertical alignment does affect the safety, but horizontal has more effect than the vertical alignment. I'll come to those things as I present. And the other part is the overtaking side distance we want to look into. So the performance which we want to understand in this presentation is about the performance of a roadway. For some reason, I think there is a patch which is coming up in my presentation. So I'll just quickly refresh the screen. So just hold on with me.
Okay, sir. No issue, please.
Yeah, I think now it is better.
Yeah,
That
it is
patch
okay. Yes,
Yeah.
sir. It's fine now.
Yeah. So now the performance-based design, when we are looking into the roadway design, basically we are looking into the roadway sections and how the driver perceives. So again, if I have to take the analogy of the mobile devices you are purchasing, whatever the design it has, whether it has a latest one, the foldable screen, or whether the apps looks different or not, that depends on the user's perception. So in this case, our roadway, it depends on the user who are predominantly driver in case of rural highways. In case of urban, of course, you will find that pedestrians are there, non-motorized transportation modes are predominating in the urban setup. But in the rural setup, generally we try to have only the motorized vehicle. And the concept of other non-motorized, we try to segregate them in the service road and so forth. So in this design, in the conventional design which you look into, which we generally do, includes the mechanistic properties of the vehicles. And this is what is followed in the IRC guideline, and which was developed or being in there from 1980 onwards. And we don't see any modification or improvement in there. This is one of the thing or the issue. I am not sure what entails, but we keep on seeing new special publications of the IRC SP, but the base code is never been or not revised till 1980. If you look into other countries' code, particularly US, we keep on seeing the improvements coming every few years. There are reasons, and this presentation may lead you to that as well. So with this conventional design, we try to look into the issues in India, which is heterogeneous traffic condition, non-lane discipline among the in the traffic or the driver. We have issues of the enforcement of law and order, and also there are a lot of high variability in road geometry. So with all this variation, we want to see the performance of our roadways and how we can consider that. So the performance, whenever we are considering, this can be broadly categorized into two. One is the longitudinal performance and another is the lateral performance. Coming to the longitudinal performance, most of you know, one is that speed is one of the longitudinal performance, longitudinal acceleration, deceleration, headway, time to collision, pedal performance. I mean, up to time to collision are quite known to you, and the side distance is also quite known to you. Pedal performance is another performance parameter where you look how people drive or how people use the accelerator and the brake in certain situation. So the research is going on to understand by the use of those pedal sensors or pedal movement to see the effect. Similarly, the lateral performance parameters or the variables which can be considered are the lateral acceleration, steering performance, so how people steer around certain situation in the curve or in certain condition. Yaw rate or heading angle, the lane position, and the lateral gap. So some of these parameter you have already heard from other, or you'll be seeing it in the published literature, and we'll be using some of those for our studies as well. Now, those parameters we need to collect data. There are many ways of collecting the data, and again, many of you are familiar with this various methods of data collection. One could be speed radar gun, which someone said stand beside the road and actually start collecting the speed of the road, speed of the vehicle, approaching vehicle. So in this, you can only collect the speed of the vehicle, so which is one of the longitudinal performance parameter. You can also have a graduated pavement, like the one bottom left you can see here. So here there are two lines and there is a graduation here, and this is another line, the solid line here, and this is another line. So if we in this case, what we know is that any vehicle which is passing, we can we know when they are passing this one first line and the second line here. By that we can always measure the speed of the vehicle. Further, you will see in the middle of the screen there is a graduated lines, the small dots across the pavement. So this is going to give us the better position of the vehicle. So if we have this kind of setup, we know the vehicle position, their speed, and we can use those facts for further design. But this is not enough, because we said about so many parameters, and this is only going to give us one or two parameters. So we need more, which is, we call it trajectory and other detail, and the trajectory from where we can actually extract variables or the parameters related to the lateral positioning and lateral behavior. So there are two other methods which we can use in that case. One is the driving simulator. So a driving simulator where we can set up the environment through which someone needs to drive, and it is in the laboratory setup. And we ask the driver to drive through those various situations. So fortunately, IIT Bombay has one of them, and we have done certain work on that. The other is also a similar way of collecting data from the field using the GPS data logger. So again, many of the institutes in India and as well as IIT Bombay has this GPS data logger, which can be used to collect data. And this GPS data logger is also synced with cameras, which can be fixed around the vehicle to get the data. And we also have certain sensors to collect the pedal force, even though I'm not presenting that part, but all those things can be synced and we can collect data from the field. So the pedal sensors are also there in the driving simulator, but only difference is that in the driving simulator, it's an artificial environment in the comfort of the lab. Someone is driving, and whereas the real world could be somewhat different. So all this needs to be calibrated. Now, with this, basically, if you want to evaluate the safety, we need to understand whether the design is consistent or not. And the safety is evaluated based on the consistency of the design. And as we talk about the consistency of the design, it can be evaluated based on few of the parameters. One is speed, another is alignment index, the third one is workload, and the fourth one is vehicle stability. And when we talk about the speed, basically the speed could be based on the design speed, or it could be based on the speed vehicle is traveling and what is the reduction in the speed happening in there. And when we looked into the design speed, we can see how, roadway which has been designed and constructed, how the design speed is varying along the roadway. Generally, we do not vary. So from the design perspective, we may find the road to be consistent. However, from the performance perspective, where we need to look into the operating speed, we may differ in their opinion. So here, when we are looking into the operating speed, it can be evaluated in various ways. One is looking into the operating speed, change in operating speed from one section to another section. And another could be when we look into the change in operating speed means change in 85th percentile of the operating speed. So another way of looking into that is like if we can track the vehicle, so and then look into the 85th percentile change of the speed. So we look into the change in speed and we check the what is the 85th percentile of that change. The first one is we look into the 85th percentile speed at two different locations and see observe what is the difference in that of 85th percentile speed. So the first one, which on the top, which you see del V85, there we are looking into the 85th percentile speed at two different locations and just subtracting from each other and see the performance based on that. The second one, which is del 85V, we are looking into the speed difference of each individual vehicle between two locations and using the 85th percentile difference of the speed and evaluate based on that. The third one is the maximum speed reduction, particularly the 85th percentile maximum speed reduction. So what is happening in all the cases is that we are looking into the speed difference, but we are not identifying where the speed was maximum and when it was minimum. So the maximum speed reduction is much more much more usable parameter, which can give us the idea of what is happening. I'll show you in the next figure what it exactly entails or what it means. So in this case, if you are looking into the figure, we are showing you the speed profile on the bottom right hand side image. So in this, as the distance goes, how the speed is varying, we are looking into that. Now in the first case where we are looking into del V85, we have already fixed two locations, and there we are just observing the 85th percentile speed at the two location and deducting that. So in this in our two-lane highway, basically the two critical locations are going to be the preceding tangent length and the curve. So mainly we check at the center of the curve and about 50 to 100 meters ahead of the curve in the tangent. In the second case, instead of just taking the 85th percentile speed at the both location, we actually track the vehicle which passes through the first location in the tangent and the second location in the on the curve at the center. So the difference in the speed between these two for a particular vehicle we look into, and we'll check what is the 85th percentile for all the vehicle which are passing through. But here you will notice that the maximum speed actually or may not be at the location where we observed. It could be somewhere else. And similarly, the minimum speed may not be at the center of the curve. It could be either on the after or before that curve. So we are unable to capture that. If you want to capture that, we need to track the vehicle all through the way and see how the speed is varying and the speed profile. And that is done in 85th MSR or 85th percentile maximum speed reduction. So these are the different terminologies. With this terminology, if we want to study, first of all, we need to find out or select a study area. And in this case, since we want to evaluate geometry, one of the critical geometries are the curve. And these curves basically are critical because a curve is connected by tangents or a curve is connected by another curve. in this particular study, we want to understand when curve is connected by another tangent. So it's a tangent to tangent curve, but someone can as well study curve to curve and so forth. So in this, so that's the successive elements which we are looking into. Tangent, the tangent to curve section, and we are looking into the basic geometric details, where we want to make sure our section is a mid-block section and has no influence of other features of the roadway, for example intersections or speed hump or any of the frictions which is there, because we want to understand the effect or the performance only for the geometry. If we want to, if our objective is to understand the performance of other factors, we should include that. But at this point, our study is only related to the geometry and we want to focus that. That's the reason we want to keep everything aside. And as I said, we are talking about two-lane, two-way roadway that is there. So we also need to understand that it's a tangent and the curve. Now tangent, when we are looking into, the tangent length can be varied, and the tangent length, if it is too small, means there will be a lot of influence of the previous curve onto the tangent. So if you want to understand that, we should keep it in that way. If we don't, in this case we want an independent tangent and curve, so that's why we chose a longer length of the tangent. So when we selected this, we had a length of 110 meter to 441 meter. Now we also want to understand the curve. So we have the curve radius which is varying from 50 to 300 meter, and in this we also want to see if there is any effect of the gradient. So only this portion of the vertical component we have considered, not the vertical curve, just the gradient. So our gradient was varying between plus minus 6%, and we use the standard carriageway of 7 meter. So again, the surroundings we need to consider. As I said, we want to only evaluate the geometry. For that, we definitely need low traffic movement, so that the free flow condition is maintained. And free flow condition criteria is 5-second headway, so that is there. Then we also need to look into the dry weather condition, because we don't want to have the effect of the weather. So if we want to study the weather condition, it can be included after this. So uniformity roadside is, so many of the sections are there, so we need to have uniform features along the roadway, because change in features is also going to have certain impact. With this, we need to study. So if we are studying, we need to find out the user. So users are our drivers. There are certain criteria for them. For example, they're supposed to have a valid license of light motor vehicle. They're in the driving age, and they had some experience, because we know the if they have less experience, they are vulnerable and they will be making mistake, and then that is not what we are looking into. We want to look into the driver who are experienced, and if we look into anything more than 2 years, we may assume that they have good experience in driving. Or we also look into the driving experience in terms of kilometer, because someone can have the license for 2 years without driving. In India, it is possible. So we also looked into their driving history to find out how much they have driven before this. So what are the source of this driver? We consider the drivers from IIT Bombay, the staff, faculty members, and as well as the professional drivers who serve various functions in IIT Bombay, who are actually private drivers, professional drivers hired for those various events like conferences and other stuff. So these are the source of the driver, and when we looked into them, we also consider the driver who are in a proper health condition. So that's the reason we need to understand that what is their medical condition. So anyone who has critical medication, we did not consider them, because that will influence the behavior rather than our what we want to know. And those could be the studies for some other purpose, but not for our case which we are seeing. And this study was conducted in the driving simulator. So driving simulator has its own drawback. So there could be a issue of driving sickness. So if we have to exclude them. Now, before this, when we start the experiment in the driving simulator, we need to have pre-experiment session where we need to explain everything to the driver, collect certain demographic and experience data from the driver, understand their health condition, and then we need to give them some time to get familiar with the simulator. And once all these things are done, then we get into the final test. When we do the final test, collect the data in the driving simulator, we need to extract. So the driving simulator has the capability of collecting data at the rate of 120 hertz. Now, if we have that amount of data, we need to apply certain method, or we need to apply certain technique to use the data which we want. For our case, we had kept it very simple. We just took the average of the speed and all the variables which we are collecting over a 5-meter segment, so that we can reduce the number of data points in our analysis. Once we collected all this data and tried to understand the performance measure, in this case, the performance measure was the operating speed, or particularly the reduction in the operating speed. And in that reduction, we want to see the influence of the road geometry, which is presented in by radius, the tangent preceding tangent length, curve length, gradient, super elevation, extra widening, and shoulder width. With all these things, when we try to develop a model, it's an empirical model, we find that the empirical model looks like this, where 85th percentile maximum speed reduction is a function of 1 by r, which is your curvature, or and the function of preceding tangent length. So this indicates that as the radius increases, the reduction in the speed, or reduction in the maximum speed reduction in the maximum speed is less, which is quite obvious. So as the radius is increasing and it becomes infinite, which is tangent, so you would see a very comfortable stable speed. But when the radius is reducing and coming to a very tight or sharp curve, you'll see that in the tangent the vehicle was traveling at a higher speed, and as they enter into the curve, they have to reduce the speed. So that is what it is indicating. Then the other parameter, PTL, which is the preceding tangent length, indicates that as the tangent length increases, again the speed change is going to be maximum or increase. So what is again happening is, if you have a longer tangent, so people are comfortable, they will be trying to reach their desired speed, and followed by the curve, then again they need to reduce. But if you have a shorter tangent, so driver might think that, okay, another curve is coming, they might not reach even the desired speed comfortably before they start reducing the speed for the upcoming curve. So with this, we also looked into the validation of the model. We looked into the MSE values. We also looked into the I number, and we found out it is quite statistically significant, our parameters, and it's quite valid. And the root mean square error is also quite within the range what has been reported in the literature. Now, we had two parameters which we need to see how sensitive it is. So we looked into the sensitivity of the parameters and found out the radius is sensitive when compared to the preceding tangent length, particularly if it differs a lot from the mean value which we had considered in this case. And so we need to be careful in the design when we are using the particular radius. So for further, what is the implication of this on the safety? We looked into how it can be considered, or how we can actually use it. And we actually looked into the various percentiles of the distribution of the speed reduction, and we categorized anything which is above 85% is going to be poor in the design, and anything which is below 50% is going to be good. With that, we set a limit of 20 km/h for the good design, and 20 to 35 for the fair, and above 35 is the poor. So the speed reduction, if we are looking into this range, this is how we can categorize our design. Now, the application, if you want to look into, we can look into the application, because we do the design, the design speed based on the radius. And when we do the design based on the radius, we can look into the design charts which we can develop from this. So this chart which you are looking into, the y-axis on the right hand side shows you the vehicle, the design speed, and from this design speed you can choose the maximum the minimum radius which you can select. So the solid line which you see on the graph, which is going from the corner to corner, is the minimum radius. So from the design speed, if you come to the minimum radius, then you know what is the minimum radius. So the line which you see coming from around 70 kmph and coming to be there at the 175 meter radius. So for the 70 km/h, 175 meter radius is the minimum radius which we need. Now, with this radius, we want to design a safer roadway. So we want to see what should be the typical preceding tangent length. So we have put this green line and the red line based on the good and the fair limits, and then basically wherever our vertical line intersects with the green line, we can go towards the left, which is the preceding tangent length, and it is indicating that the preceding tangent length, if we have about 185 meter, then you may not see the maximum speed reduction beyond 20 km/h. So this is how we can choose our design, and we can have a design which is based on the performance base. Now, this is from the design speed perspective. We can also look into from the lateral performance. So this is one of the another important parameter. So the lateral performance is the lateral acceleration, and the lateral acceleration, whenever we are looking into, there is a limit in the lateral acceleration based on the super elevation and the friction factor which we provide, and anything beyond that is going to be unsafe, and it could be an issue. So in this case, basically we are looking into the lateral acceleration which exceeds the limit value. Now, when we look into this lateral acceleration, we are seeing there are a lot of the amplitudes is changing over the distance of the curve. So we need to understand that how we can capture this. For this, we used one theory which is coming from the solid mechanics. Basically, we use the moment of area about the y-axis to understand that. And we divided our lateral acceleration into small strips, which you can see in the bottom left image. And then we took for each strip, what is the moment of area for each. And then we normalized it based on the length. So that is what is giving us the equivalent critical lateral acceleration. So with that lateral acceleration, we try to evaluate the situation, what is happening in the roadway. In the process, so we got a lot of lateral acceleration values, index like that, which we try to group and using the hierarchical clustering method. And when we tried to group, we got the three groups RG1, RG2, and RG3. So these are the three groups which we got from the lateral acceleration values obtained from the test. Again, this experiment was conducted in the driving simulator because this is quite dangerous in certain cases. For the example, the last row, which is shown in the red, these are the cases where actually vehicle run off the road or basically overturned. So when it overturned means there was an accident, and if we are trying to see this thing in the roadway, it is actually dangerous, which is very difficult to get into that. So this type of experiment can be conducted in the driving simulator. So we could able to get such events, about 13 or 14 of them, and we could record the equivalent lateral acceleration and compare that equivalent lateral acceleration statistics with the three groups we got, or the clusters we got from the other driver who did not meet into the accident. And once we compared, we found out that the accident situation is very close or meeting the RG3. So RG3 we are considering is like it's more unsafe or severe unsafe. So we need to investigate this group. So accordingly, we have named them. We named the group which is there in the RG3 as the high risk group, and the RG2 as the moderate risk, and RG1 as the low risk. So once we do this, basically we use the generalized linear mixed model to find out the probability of runoff, getting off the roadway, or basically turning over, or side slip, or turning over. In this case, when we looked into the probability and tried to develop a model, we got a model like this. So this model is indicating when in this model we have grouped the RG1 or the high risk group versus we want to compare with the low risk group, which includes the moderate as well, low and moderate risk group. In the other case, we try to model if we consider both high and moderate risk group and try to compare with the low risk group. So we got two different models considering how we assume or consider the data which we got. So in the first case, when we are comparing the high risk group with the low and moderate risk group, we find the model which is on the left hand side, where we are seeing that the risk is going to increase as the radius is going to reduce. So if the radius is going to reduce, the curvature is going to increase, and as the curvature increases, it has a multiplication factor of 237.56, which means it is going to increase. However, when we are looking into the gradient, as the gradient increases, we are seeing the high risk is going to reduce. And this is exactly the same when we are looking into the high and moderate risk group versus the low risk group. So it is giving us the sensible trend in the same way. Now, if we have also looked into the mixed effect of the curvature and the gradient, so together also it has a positive correlation. So this is what the model looks like. If you want to present it in a graph, this is what it looks like. So high risk probability for the risk probability of high risk group versus the moderate and low risk group. So in this case, when we see the curvature which is in the x-axis and the probability of risk which is on the y-axis, you take any of the radius. Suppose you take the 75-meter radius, and as you change the gradient, which is you are going in the down from the positive gradient, which is 6%, you are going towards the negative gradient, which is minus 6%, means you are going from the ascending gradient to descending gradient. As you change the gradient, the risk is increasing. So it is very clear that for a given radius, as if you are going in a down gradient or the descending gradient, the risk is going to increase. Likewise, if you want to change the radius from a particular one to the another one, for example, if you consider the radius 75 and the 100, for the same gradient, you have to move towards the left along the line. So if you take the gradient 0, which is at the middle, the black line, if you try to move along the line, you can see for the same gradient, as the radius increases, the probability of risk reduces. So which explains, like, if you have a generous radius, the risk is going to reduce, and this is going to help us to quantify that, assess that, and this is the performance which we can use it. Similar way, the other group which we are looking into, the risk, if we are want to combine the high and the moderate risk and compare it with the low risk, we are seeing the similar graph. And here one thing to observe is that if we combine the high and the moderate risk group, the effect of gradient diminishes as the radius is decreasing. So if you want to consider all the risk factor, basically 50 close to 50-meter radius or less, the gradient does not matter. But in the other case, the gradient does matter. Now, this was for the grouping based on the risk. We further looked into the geometric grouping. So what is exactly happening in this group, in this risk group? And the geometric parameter which we looked into are the two geometric parameter. One is the radius and another is the gradient. That is what we saw in the previous two graphs. And the third one which we looked into is the preceding tangent length, because that was also coming up in our model. And all these things are designed based on the design speed. That's the fourth parameter which we looked into based on the geometric design variable. So with this, when we try to look into the plots in the high risk, moderate risk, based on the radius or based on the design speed, what we are clearly seeing is that as the radius of curve reduces, particularly when it reduces less than 100 meter, the risk increases quite much. And particularly, you'll see that the risk for those cases between the high and the moderate risk, the ratio changes to an extent up to 2 to 3-fold. And similar thing can be seen when we are comparing the speed. So speed, when the speed is reduced, the design speed particularly is reduced to less than 50, then we see a considerable increase in the risk behavior. So if we keep our design speed high, which indicates that our radius should be larger, then we can actually have a very low amount of high risk events. So when we are designing, we can use this fact to design. Now, similar thing, we can look into the gradient as well as the preceding tangent. And this, if you are looking into the effect of the gradient, is mild, even though it is there. But between the high risk and the moderate risk, there are certain differences. And but between the gradient, it is comparatively less. Now, coming to the preceding tangent, again, the effect of that is comparatively less, but still we can see some effect. Now, we need to understand which parameter we need to use when and how. So for this thing, we looked into the chi-squared automatic interaction detection method through the decision tree diagram. And it is a data mining algorithm which we used. And when we looked into all the clusters based on this, we found out that when the design speed, the tree at the end node of the tree actually indicates what is dominating in which situation. So in this case, these end nodes are marked by the number 1, 2, 3, 4, 5, 6, and 7. So if we see that way, the end node, the first one is one where the design speed is less than 50. Once the design speed is less than 50, we don't have to bother about any of the geometric parameters. We have to bother about the design speed itself and see how we can increase the design speed. Now, when the design speed is between 50 and 60, rather than bothering about the design speed, we need to look into what we can do with the geometric parameters, particularly with the preceding tangent length. So the preceding tangent length becomes a governing factor in those cases. Now, when we go to the design speed between 60 and 70, instead of the preceding tangent length, the gradient becomes a dominating factor, and the same as well for the design speed when it is more than 70. So we can use this information for the better understanding and better evaluation of the performance. So this work is under review in TIDE, and hope we are expecting it should be published soon. And you can see those results in there as well. Now, this was from the geometric point of view. We also tried to look into the socio-demographic factors of this. And when we looked into the socio-demographic factor, basically we are looking into the age, gender, occupation of the drivers. So you want to understand whether those things have any effect, any effect on the overall safety aspect. And again, when we use all these factors, all the various factors, we try to develop a generalized linear mixed model with the socio-demographic factor, and we use the binomial distribution as a link function and try to develop the model. And again, we had, as I said, that we had the three risk groups: high risk, moderate risk, and low risk. So the same risk group we wanted to model, and once we tried to model based on the socio-demographic factor, again based on the high risk versus low and moderate risk, and high and moderate risk versus the low risk, what we are seeing is that age has a positive effect, experience also has a positive effect, and age has a positive effect in case of mid-age. So if it is a mid-age, then only we are seeing the positive effect. Experience, if it is a mid-experience, that also has a positive effect. It will be understood better when I show you certain plot, which is going to give you the meaningful interpretation. So when we are estimating the probability versus the percentage of share of risk, we looked into the age and the experience. So what we are finding out that young age with low experience, which is someone very young and they are trying to learn driving at that stage, their probability of risk is quite low, and their percentage of high risk events with them is comparatively low compared to the young driver who have who have some experience with driving, as well as the mid-age driver who are just trying to learn driving. So coming to the driving, it gives an interesting information that if we train drivers at the young age, so probably at the beginning of their driving training, they are of lesser risk compared to the mid-age who are trying to learn driving at that stage. But once the young drivers learn little bit and become a mid-experience, they are the group who are actually in the high-risk categories. And they are comparable with the mid-age, low-experience group. So this is where they are vulnerable, and we need to monitor them and carefully observe them in their performance. So this is where there are certain programs called graduate driver training program, where there is a longer observation, or basically we observe how the driver is performing when they are in that stage. So this type of program might help in those situations if we keep monitoring, and if we keep not only monitoring, basically give them the guidance in the process. But when the experience increases beyond that, from the mid experience, we find that no matter whether they are mid-age or young age, they tend to become safe drivers comparatively. Now, this is for the high risk versus the moderate and the low risk. Now, if you look into the high to moderate risk versus the low risk, we do see, means we are grouping the high risk as well as the moderate risk together. We do see certain trend. In that case, again, the trend is very clear that no matter the young drivers, whether they have the mid experience or the high experience, overall they are taking more risk compared to the mid-age driver. Now, young drivers, when they have low experience, still they are better than the mid experience and the high experience drivers. So, so that concludes, like we looked into the behavior of the driver as a performance. We looked into the geometric for the performance, and we can evaluate the whole system. This is how we can evaluate based on the performance of the geometry. And this particular work has already been published. So the paper is indicated there. Now, another component we indicated at the beginning is the side distance. So I'll quickly move on to the side distance now. So one of the side distance which is quite critical in the two-lane highway is the overtaking side distance. And overtaking side distance, one of the component is we need to know what is the overtaking distance, how much distance vehicle is traveling to overtake another vehicle. So if we look into the literature, the overtaking strategies, there are various overtaking strategies, and these are like accelerative overtaking, flying overtaking, piggybacking overtaking, 2+ overtaking. In all these things, you will find that the accelerative overtaking is critical. That is what is considered in the overtaking side distance. So accelerative overtaking is where a slow-moving vehicle fast-moving vehicle first follows a slow-moving vehicle, and when opportunity arrives, the fast-moving vehicle changes lane, accelerates, and then completes the overtaking of the slow-moving vehicle and returns back to the lane. So this is called the accelerative overtaking. The other type of overtaking are different, where they don't actually change the speed, and so many other things are happening. For the brevity, I'm not going to get into that, but you can look into the paper which we are working on, which is going to be published soon, or any other paper you can refer for that. Now, for this instance, we again looked into this time field study. Basically, we looked into the National Highway 222 between Thane district in Maharashtra for the two-lane overtaking process. So we had about 28 local drivers who drove through this, and in this, when they drove through this area, we did not give any instruction. It was an instrumented vehicle. I'll show you the instrumentation. And we recorded about 117 accelerative overtaking incidents during this driving. Now, when we looked into the speed profile of the various vehicle types, we found out that the passenger car has the highest speed among all the other vehicles which are plying in that roadway. So this is the reason we choose passenger car as the overtaking vehicle, and all other, including the passenger car, another slow moving passenger car, as the overtaken vehicle. And this is what the instrumented vehicle looks like. We had fit 3 different cameras. So camera 1, camera 2, and camera 3. Now camera 1 which is on the top of the vehicle, is actually looking into the front of the vehicle, which is, you can see on the right hand side, the camera view. So we know like where exactly our vehicle is, where the slow moving vehicle is, and accordingly it's going to look into it. Camera 2 is looking sidewise, so that you can see on the right hand side the view, camera view. So again, it is looking into our vehicle position with relate to the slow moving vehicle when it is overtaking. So this view does not show the overtaking vehicle, so that's the reason camera 2 view is only showing the side of the roadway. Camera 3 is on the back side of the vehicle, and it is only looking into the rear of the vehicle, just to see when the overtaking is completed, how how the overtaken vehicle looks like or where it is positioned and so forth. So we use certain image analysis process to get various values for the relative distance between the our overtaking vehicle and the overtaken vehicle. We also looked into the position of the overtaking vehicle with respect to the road edge, so we know when the overtaking vehicle is crossing the lane. So all these things done based on the camera calibration, and before we actually go out in the field, we do the calibration of the camera and then extract the data, as it's a semi-manual process which we use. So currently this work is under review and we are hoping to be get published soon. So the variables which we looked into were the overtaking distance, overtaking time, and the that are the dependent variable. Based on the, we studied those variable based on the overtaking vehicle speed, overtaken vehicle speed, average speed difference, longitudinal gap between the two vehicle, speed of overtaking vehicle at start and the end, and also the maximum speed. Now when we look all these parameter, this is the descriptive statistics. I'm not going to get into that much, but we'd like to get into the model. So when we developed the model, we found out that the speed or the overtaking distance is depending on the difference in the speed of the overtaking and overtaken vehicle. So that is the del VAB. So average speed of overtaken and overtaking vehicle. So it makes sense if the difference is large, basically your overtaking distance is going to reduce, and as well as the same thing can be observed for the overtaking time. So overtaking time is going to reduce. The another thing is the parameter which is showing up is the headway or the gap between the overtaken and overtaking vehicle, the total gap before, considering the gap before the overtaking and the gap after the overtaking. So together, whenever we are looking into that, it again makes sense. It has a positive factor or coefficient, which indicates that if you have larger gap, that means you need more distance and more time. Now the third one is we are looking into the overtaken vehicle speed, which is VB. So overtaken vehicle speed or the slow moving vehicle speed, it is very clear that if the overtaken vehicle speed, if it is traveling at a high speed, then the distance and as well as the time is going to increase. But it was not prominent in the case of overtaking time, so you won't see it in the model. Now there is also the effect of the vehicle, which is the light commercial vehicle and the heavy vehicles. So heavy vehicle, we consider the trucks as well as the buses. So definitely if you are comparing the overtaking distance particularly, and if that is a heavy vehicle, we see the distance is going to increase for the same exact speed, and if all the condition for the heavy vehicle, we need additional 32 meter or somewhere close to 32 meter, 33 meter compared to car. Now in this model, basically you'll see that the three-wheelers are not coming into the equation. This is we realize that the overtaking maneuver for overtaking a maneuver while over three-wheeler and a slow-moving passenger car is almost same. So basically, if it is a slow-moving passenger car or a three-wheeler, it will require equal distance almost, particularly in the two-lane rural highways. So this is what the model looks like. So when we try to plot, this is how the different vehicle categories are going to look like. So you can see the passenger car and the motorized three-wheeler are combined in this plot, and these are the plot when which is indicating the overtaking distance when a passenger car is overtaking a slow moving another passenger car or three-wheeler or LCV or heavy vehicle. Now this is what it is. If we understand this thing, we need to compare with our design practice what we have. So if you are looking into the design practice, the design overtaking distance which is there in the IRC, and we also try to compare with the ASTO. We compared with ASTO two different ASTOs, 2001 guideline and the 2011, because there is a significant change in ASTO guideline between 2001 and 2011. And when we compare, we can find out the solid line, which is we obtained from our model, our study, is to some extent very close to the ASTO guidelines, even for the 2001 and the 2011, even though we see some difference, but it is quite way different from the IRC, and particularly at a higher speed, we are seeing that the overtaking distance is quite less than the IRC prescribed distance. So, which indicates that many places we might be saying that overtaking is not safe, even though the driver can easily overtake that. And this actually indicates that over the time, driver will lose trust on what we are saying on the roadway. So, and once they lose trust, they will lose the respect on the design and whatever signages we are going to provide. So it needs to be done properly, where driver can see that whatever they are performing and it is reflecting in the design. So same thing, we try to compare. This is the overtaking distance only. We try to compare with the overtaking side distance. So as we look into the side distance, again we see that the IRC, what it is providing is comparatively high, particularly in case of higher speed, design speed. And IRC is actually saying low in case of the lower design speed. So in both cases, there could be a trust issue on the design which we are providing to our road users or the designer. Now, when we compare to the ASTO 2001, basically we see that ASTO 2001 was quite high compared to our design, and possibly you can think this is the reason why they ASTO thought of choosing to revise the design guideline to get it more oriented towards the performance of the driver, and that's why they have come up with the ASTO 2011 and the other model where they are choosing indicating that the overtaking side distance is quite less than the 2001 guideline. Now we cannot directly compare the overtaking side distance of the ASTO 2001 with our study. The various reason, one of the reason is that the vehicles which are there in US are quite powerful compared to our case, and also many times they do have tractors on these rural roads and they need to overtake them, and that is where they were considering, and that's the reason overtaking distances were coming, side distances required for the overtaking a tractor is quite less. So we haven't compared the factor of the tractor in this case, so that's the reason it is quite different. So in a nutshell or in a summary, we can say that if we the linear regression model of the 85th MSR is quite significant with the radius and the preceding tangent length. It is quite useful if you try to develop this model countrywide, and you can use to see the performance-based design, which is quite getting traction in all the different countries of the world, but we haven't even updated our design from 1980. So we definitely can leapfrog and actually adopt this kind of policies, design policies. So these tools, whatever we are discussing, can be used for evaluating the safety of our existing design. We can also use the lateral acceleration for the performance as well. So all these are going to be there. We are also seeing that the radius and the gradient together, it has an impact. We are seeing that age and experience also have an impact. So these are going to be the radius and gradient when it is an impact. So in the design, we have to consider these two things together. If you recall that in the design, we have the grade compensation. So this is what is indicating about the grade compensation related to when you see the combined effect. We haven't get into the grade compensation part of it, but it can be easily got into that level. Now, age and experience, it does matter in the driver training program and the other details, and it can be considered in that way. So another part of it is that the overtaking we are seeing that it significantly varies between the vehicle types. So heavy vehicle require longer distance, which is quite obvious, and we can definitely use a calibrated camera for this type of data collection, and we can develop a better model, which is more realistic and which is appropriate for our roadways. So with that, I would like to show you some of our publication where this work are going on, and also the publication from the other authors who we have heavily referred in this presentation. And I'd also like to thank the contributors of this presentation. So basically, my role was only to supervise them. So it is the hard work of mostly Mr. Tushar Chaudhary, who is actually doing his PhD and is about to complete his PhD, and Mr. Bharat Bhadrecha, who did his MTech here at IIT Bombay and currently working with Daral as a consultant, as an transportation engineer, and he's located in Pune, and also with Professor Anuj Budkar, who is currently a faculty at IIEST. He had helped us with the data extraction from the video analysis, and we used his methodology to extract the data from those video images. So with that, I would like to thank you all. I'll take up the questions, any from the moderator. Yes. Yeah, I can see that it's only thing from where to start. That is what. So there are a lot of good morning beginning. Let me see. Okay, so one of the question came from Anna Varghese, that shall we consider the average speed of vehicle for designing purpose in terms of percentile? So average, so far the design speed we are considering 85th percentile. We do not consider the average speed. Now, so there are something about the feedback form, and I believe that the organizers are going to circulate that. So a very interesting question came from Ravi Sriram. So how accurate are the results from driving simulator and data loggers with GPS with respect to field collection points? So data logger with GPS, first of all, is from the field data, and we have actually verified the data logger data with field data, comparing with your radar guard as well as the track length, and we found it is not significantly different from any of these. So which again, in one of our published literature for the 4-lane highways is there, those comparison, and it clearly shows that there's no difference. Now coming to the driving simulator, so the driving simulator validation has not been done in our case with the field, but from the experience from the literature, what we can say that if we are just looking into the speed in driving simulator is expected to be about close to 10 kilometer per hour higher than the field speed, and this comparison is going to be we'll be soon doing that comparison. But when we are doing the relative comparison between the driving simulator speed, there should not be an issue, and in this case we have done the relative comparison in all the cases, because we have used the 85th percentile maximum speed reduction. So which is a relative comparison of the speed. So another question is there from Ades Srivastava. Can we or cannot provide any method in vehicle who also control speed of vehicle, like if speed is 40 kilometer per hour, then vehicle not cross 40 kilometer per hour. So I'm not sure the context of this question, but I believe this question context is related to the overtaking. If we look into the overtaking situation, basically the field data collection, mostly you will find some of the literature where they have controlled the speed of the slow moving vehicle, which is instrumented vehicle traveling at a particular speed in there, and then basically using that speed they have studied it. So that is one of the questions which we are looking into. And then the other question in our case, actually, I would like to clarify is that we have used the instrumented vehicle, which is actually overtaking. Now, what is the difference between these two? Of course, both has its pros and cons, because if you are actually controlling our vehicle, then the other vehicles are not controlled, and we do not have the information of the other vehicle, whether what is the effect of the driver. Now, even though we haven't studied the effect of the driver, but we have the data which we might think of considering in future, and that is going to be possible if we have the instrumented vehicle, letting the instrumented vehicle overtake the other slow moving vehicle. So there is another question from Anna Varghese, is that I think it's 80 kilometer per hour is isn't it very high for an undivided highway? So in short answer is no, it is not very high. But if you look into the design code, the code says that for the state highway, the speed can be 80 kilometer per hour, and it can be even 100 kilometer per hour for the state highway. And many of the state highways are actually two-lane undivided highways. And if you consider the context of the developed countries, they do have speed which is more than 100 kilometer per hour. So another question is, I think, same thing related to the speed from Wajat Nasser. But considering that the highways connect for freight movement and also during the night. So what we are considering the freight movement and the night, here is something which we are forgetting, is that as we improve our highway, our vehicles are also improving. There are a lot of heavy vehicles which are coming in our roadway that can travel at a speed quite high, which can easily reach 80 kilometer or 100 kilometer in our roadway. So we cannot design, I mean, our designs are going to last for years down the line. We are not designing for the vehicles which are which are going to be slower, and came in the market 20 years back or so. And nighttime, again, the nighttime issue is with the lighting. So again, if you see the vehicle lighting, that is also improving. With that proper lighting, it is this speed is quite achievable and it can be done. So another question is from Sekhar Singh. Please tell, for who doesn't have the technical knowledge like ordinary person, who can we make him or her aware of the reducing accident or jam conditions? So this is constant effort. This is not part of the presentation. It's a constant effort which needs education and training, and there are many ways of doing that. So I won't get into the details of that because it's beyond the scope of this present presentation. So again, our Srivastav's question was related to pedestrian, bicycle who crosses by heavy vehicle and all those. So here is something which you which I indicated at the very beginning. Rural highways are meant for high speed between inter district or inter cities. So in those cases, if there is a considerable volume of bicycle which are coming to the roadway, we need to develop a facility, separate facility for them, because these are the motorways where the slow moving or non-motorized are not supposed to come. It is coming from the law enforcement, and those we need to work hand in hand. And if there is a demand, definitely we have to provide facilities for them. We cannot let them come on this roadway. So some question I might have skipped something. Something I got from Nitu. How the field data was analyzed, manual or using any tools? So the field data, which is quite large, it cannot be done manually. We have to use certain statistical tools, softwares, for example, R or SPSS or any relevant software. So there is a question from Mr. Reddy. Can we ask the IRC to review the standard? How confident are we? We are definitely we should ask the IRC to review the standards, and confidence comes from the experiments being conducted. So if you are aware of the recent Indo highway capacity manual, that those experiments or those details were data was collected from the field over a few years, and then all over the India once it is compared, and then they came up with the Indo highway capacity manual. So similar initiative is needed. So we have studied one part of the country. It needs to be done for the whole part of the country, and this is how all the countries does to update their manual, not sitting like who is going to complete the study or how we can gain the confidence, but rather they create a means to gain the confidence on this thing when they start seeing the issues. So our study is only indicating the issues which can be looked into the further studies. So you can interrupt me if I'm running over the time. Otherwise, I can continue. Okay. So thank you. So what's your suggestions on changing the fundamentals in the IRC course? The suggestions, only one suggestions, keep looking for the updates. So Dhatri, I got there is a question. I got the mail from you today. Oh, so this is a separate thing. So again from Mr. Reddy, can we recommend? Okay, no, that is done. So someone did not put his name, but like to call by the great gaming person. So want to know what is the virtual driving? Is it for the gaming driving or is it for the education? I'm not going to answer question if there is no name for the person. Again, some other questions are from there from the great gaming person. So I'm considering those questions as related to the gaming, not for the education. Ryan Moniz have a question considering the drastic changes in the performance of the vehicles, comparing the time code whoops were formed, isn't the speed restrictions should be modified. So I'm not clear exactly what Ryan is indicating. So if it is related to considering the performance of the vehicle, the restrictions means the speed limit and all those needs to be evaluated. Yes, it is the need of the hour which should be done. Yeah. Okay. Thank you so much.
Okay, Majid sir. Thank you very much.
Thanks to all of you for hosting and giving me the opportunity to present the work which is being done by my research group in last few years. So hope to see you again and hope you continue with this good presentation.
Sure, sir. Sure.
Thank you so much.
I extend my invitation from NIT Silchar to you in future, sir.
Sure.
I'd like to see you in NIT Silchar. Thank you.
Okay. Thank you all. Thank you all for listening to me.
Thank you so much, sir.
Yeah. Yeah, I'm doing that. Okay, thank you. I'll be exiting the meeting as well. I have another need to go back. Okay.
Yeah, thank you. Present. Thank you very much. Yeah, am I audible?
Yes, sir.
Okay. The slide is on.
Yes, sir.
Okay. Thank you very much for the nice presentation. Good morning to all the participants and the experts present in the meeting. So I, on behalf of NIT Silchar and the organizing committee member, I welcome all the participants again to this webinar. So I will present today a topic which is very relevant, that is urban transportation system planning, some issues and challenges. So you can see my email address, etc. If required, you can contact me. So let us start. What do we mean by transportation system? Or what is urban? Or what is rural? And what do we mean by planning? So if you want to see just in the last presentation, Professor Maji, he has explained one thing in the very first slide, that road, vehicle, and the driver. So how they are behaving to each other. That is nothing but the transportation system. And if you want to say what do you mean by transportation, it's basically movement of people and goods from one place to another place. That is nothing but the transportation. Then if you want to say what is urban, or what do you mean by metro, city or town, or say rural area, or say rural. So basically, as per the census of India, any settlement having population more than 5,000 is treated as urban. That is, less than 5,000 population is nothing but the rural, and more than 5,000 is treated as the urban area or the market area. Then what is planning? Anything we do in our future, anything we plan to do, that is nothing but the planning. That may be related to any activity in our daily life. Maybe as simple as that, after getting the invitation of this webinar, you have registered for this, thinking something, and thinking that you will be attending this. So that is also nothing but part of planning. So anything that we do for the future is nothing but planning. So when we use it in our transportation field, it is called transportation planning, which consists of various terms like vision, mission, goals, strategies, and action plan. Those are the various terms associated with our planning. I'll discuss. So again, whatever I have said, the transportation system is consisting on the road, the vehicle, and the driver, and their interaction, and the nearby environment, nearby area, nearby land use, to satisfy the demand of the urbanities. So this transportation system can be split into two main components, that is demand and the supply. What is the demand? Demand is what is need of tomorrow in terms of movements of people and the goods. And the supply is how we are supplying the system in terms of vehicle, in terms of road infrastructure, in terms of the other things that is required for the transportation system to function wholeheartedly. Again, if you go back to the planning, it is the process of defining the future policies, goals, investment, and design to prepare the future need to move the people and the goods from its origin to its destination. It deals with the development of comprehensive plan for the construction and operation of the transportation facilities. If you consider the concept of urban transportation system, you can say the urban area consists of the household, the workplaces, the services, the transportation facilities, the government organization, the regulation, etc. So within this system and their subsystem, and including all the activities, all are supported by the transportation system. So here we can see whatever I have said is that this is the transportation supply part, this part is the demand part, and this is the activity system. So these three are interrelated. Let us first see the transportation demand part. This I will discuss again, how to evaluate this demand. It is basically the demand of the user, the spatial distribution of the demand, etc., etc., finally the mode choice and the flow in the network, that is the amount of flow or amount of traffic in various road network. On the supply part, what is the total vehicle you are supplying? What is the amount of road network we are supplying? What is their capacity? What is the level of service of the vehicles? What is the level of service of the road network? What level of congestion, etc. So depending on the demand of the urban area and the supply of the transportation system, these two again will depend on the activities. If you see the level and the location of the activity and the space available to locate the activities and other infrastructure, it will also create the further demand. So all these three activities, the transportation demand, supply, and the urban activities, they have to go on simultaneously. The transportation planning is a continuous process. It is a dynamic process. Just few minutes back, even Majid-sir has said that regarding the improvement of the IRC, even the ASTU has revised their code in 2011. So it is a dynamic process. Whatever you are thinking today will solve the transportation problem of a particular area or a spot. That may not be feasible in the next 5 years. 5 years we have to do something more. So it's a dynamic process. The process should be rational rather than political. Many times the transportation planning policies are political, particularly in Indian condition, but that should not be the case. It should access opportunities and limitation of the future. That is, what is the opportunity we have? What is the limitations of the future in terms of technology, in terms of the fuel constraint? So in next few years, we will be short of our fossil fuel. And what is the alternative fuel? So those are the things we need to consider in transportation planning. It should also be short runs and long runs perspective. That is the transportation planning, whatever we call as comprehensive plan, may extend 25 to 35 years. But the implementation plan should be either 5 years or just 1 year. So the short runs problem and long runs problem all should be solved through the transportation planning process. So the goals, objective, performance measure from the basis of measure of effectiveness in the evaluation. So evaluation is one of the most important criteria. The decision maker of the urban transportation system planning are the appointed government official who provide and maintain the transportation system that meets the mobility and accessibility of the populations. Why I'm telling all this is that it is not only the decision maker, it should also include, other than the government officials, the expert in the transportation field, maybe the transportation planner, or he will be the transportation engineer, the economist, the geographer, excuse me, were all related. So they should conform to this decision-making process. Under transportation planning, the different practices such as urban development, urban transportation policy, legislation, funding bodies, project management, etc., all come together. Finally, the aim of the transportation planning is to provide a sustainable transportation system for the society. So finally, this is one of the things, or one of the diagram, you can say, what are the things that comes under transportation planning process. So whatever you have seen in transportation modeling, this is the modeling part or the research part. Then from here, whatever policy you generate from the generate, that is the administrative, it's the law and legislation through the institutional framework. This law and legislation should be implemented through a expert professionals who is very skilled in nature. This may be the field engineers, it may be the transportation planner, it may be the traffic engineer, it may even be the traffic police to control the system. And finally, the communication with the decision maker, the public, and the media. That is, whatever decision is being taken, how that decision is being transmitted to the user of the system. So everything needs to be put under the same umbrella, and all the transportation planning related persons or involved people should work together to make the system perfect one. During the planning process, these are the various types of plan that we have. One is comprehensive plan, that may be 25 to 30 years duration. Master plan, which is we have for all our urban area, which may be normally it is for 20 years master plan. Then 5 years implementation plan. The way the government of India's that 20 years plan is divided into 5 years. Similarly, every plan should be divided, and the final implementation plan, that may be even 1 year. That is also we call as the execution plan. What are the basic issues then? That is what to plan, where to plan, when to plan, how, who are the people there involved, and why to plan. That is all whatever you are saying, what is our goal, what is the vision, what is the mission, everything we need to consider. So let us go further. To understand these basic questions, let us raise some question ourselves. Where we are, it is the question respected to your say our existing urban area for which we are thinking of the transportation planning. It means to evaluate the existing condition, such as the trend, the condition related to the population, the transportation condition of the urban area, etc., etc. That is, we have to know the system first. Then where do we want to go? That is, what is our goal? If you say, for example, in a scale of 10, if 10 represents the 100% satisfaction plan for the user, and 0 means the users are very unsatisfied, then up to which 7 or 8 we want to reach through our planning, that we have to decide. Whatever in NBA accreditation, we call it the satisfaction level. What is the satisfaction level? That we have to decide. So that we can do through the major issues, the obstacles in future, and what are the opportunities in future. Then next question we can raise is what or who will guide us? That is, if you want to do something, then somebody has to be there to help us. We may not be expert in all the field. That helping hand is nothing our mission, the mission statement, the goals, the objective, the input parameters, the performance measures, etc., etc. And how will you reach there? We need the funding, we need the detailed program, we need the implementation agency, we need the policy measures, various laws, various implementation agencies. So these are the various things that will help us to reach there. So out of all these, the revenue estimation for the fund, where from the fund will come, that is one of the very important things. That is called the economic criteria of any plan. So as an engineer or as an economist, we know what is the value of economic for related to implementation of any of the plan. So when the government used to fund any project or grant any project, the first thing they will look after the technicability, it is nothing but the economic consideration. So this is very important. So if you see the rational approach of planning, as whatever we have discussed till now, defining the goals and objectives, then to identify the problem, that is where we are, whatever I have discussed in my earlier slide. So after identifying the problems and defining goals and objectives, we have to generate alternative plan. That alternative plan may be 4, 5, 6 numbers, 6 or even 10 numbers of alternative solution. Then out of that alternative solution, whatever we have generated, we need to evaluate to find out the best alternative. So for that, we need some evaluation parameter. One of the very important parameter is nothing but economic criteria. Other technical feasibility, then say in case of our transportation, the distance or the travel time or the travel distance, etc., the comfort level you are providing, the safety level you are providing, those may be their alternative criteria or the criteria to evaluate the alternatives. On the basis of the evaluation based on the criteria selected, we have to final objective is to find out the optimum alternatives. And that alternative, whichever is finally selected as the best alternative, should be implemented and suggested to the government for implementation. And this plan will actually go for execution level. How to evaluate the transportation system? So if you see just 3 terms, ubiquity, mobility, and efficiency. Ubiquity gives us the accessibility to the system. Mobility gives us the amount of travel or the amount of speed that can be satisfied with our system. And what is the efficiency of the system? That is basically the efficiency is the output by input. Now, all these parameters, whatever we are considering for computing the output and the input, should be in the same unit. That we should be very careful. Output may be in terms of tonnage or the mileage per hour or the number of passengers carried per hour, etc., etc. And the input, the initial cost of the infrastructure of the vehicle, the operation maintenance cost, etc. Again, I am saying all the unit has to be converted to a single unit, maybe in terms of rupees, to find out the efficiency. So we say, is this ubiquity, mobility, and efficiency is to our satisfaction level, then we'll say that that transportation system will be satisfactory to the user. With this general background, now if we go to some part of the history of the transportation system, just to give a flavor of what we are talking about. Basically, the route started about 3,500 BC. Sorry. I'm extremely sorry. So after the development of agriculture, if you go back to the history, after the development of agriculture, the resident become fixed and the field become fixed. Then there was a to and fro movement between the residents and the field. So from here, the roadway starts. Before that, the nomad people, they were traveling in a open traverse. So there was no concept of road network prior to the development of the agriculture and settlement. Even if you see our civilization, that is Mohenjo-daro and Harappa, or our say, Roman civilization, etc., whatever civilization you consider, it's about 3,500 years BC. Even in Mohenjo-daro and Harappa, we have the proper road network system. Even the gradient, etc., was considered during that period also. So the basic concept of road start from here. As soon as the road starts, the concept of vehicle. Somebody saw that log was coming down from the hills. That was nothing but the concept of the wheel. And finally, we have the IC engine. And in 1886, the first automobile, the diesel locomotive in 1921. Okay. Then 1950s interstate highway in USA, almost similar to the national highway in Indian condition, etc., etc. Now we have landed to the moon, and finally we're trying to go to the Mars, etc. So all are nothing but the various development of the transportation system. So how this system evolved, that is the important thing we need to consider. If you see the modes of transportation, basically if you want to understand the transportation planning, then you have to see the modes also. So the modes from our school level, we are learning that land-based, water-based, and air-based. So today, whatever I am interested to say is that land-based and water-based, the fuel is required or the energy is required for horizontal movement only, one directional movement. That is, we have to overcome the friction to move in the longitudinal direction. So energy is required to move in one direction. But as soon as we are going to the air, in that case, two directional movement is to be afforded. That is the horizontal movement, as well as you have to keep the weight of the aircraft in suspension. That is the vertical movement. So we need more fuel in case of air-based transportation. And this is the reason we need more fuel, and the cost of the air-based transportation is far, far more than the other types of transportation. In case of railway and highway, railway, the steel wheel moves over the steel rail. So as you know, compared to the, whereas in case of highway, the rubber tire moves on bituminous or concrete surface. So definitely you have understood the friction is much less in case of railway. So we have to basically overcome the frictional forces to move the people or the goods. So that is why the railway is cheaper than our highway. Similar is the in case of water body, the ship, ferry, etc. The water is there to support our vehicle. We have to just move in the longitudinal direction, but the speed is not as desired in case of highway and railway, and that is why the water-based transportation is one of the cheapest mode of transportation. So this support system and the cost involved, these two criteria are very important to understand if you want to understand the mode of transport. Okay, then I am giving you another concept, the total urban transportation systems. Say the schedule with respect to schedule and the road, that is at the top you will see the time or the schedule, this diagram, block diagram. This side is the space of the road. And then the time is also segregated into two parts. So this fixed, this part is time fixed, and this part is time is variable. That is schedule is variable. This is something like this, that the rail or the train will, movement of the train, it is already declared. Your aircraft movement, the flight schedule is already declared. Those are nothing but the fixed. Whereas when you want to go out with your personalized vehicle, say your two-wheeler or car, personal car, you can go out at any time. So that is nothing but the variable time schedule. On the other hand, this is space on the road. Again, for some types of transportation modes, you will see that the routes are fixed. That is even for our city buses, the routes are fixed. The city buses cannot deviate out of their route. The train line, the flight route are fixed. Whereas some modes are there. You want to go to, say, a nearby market with your personalized vehicle, you can take any of the road. Maybe to your left, right, 4 or 5 alternative path is there, then you can take any of the path as per your convenience. That is nothing but the road variable, this part, bottom part. Now, out of these, depending on the schedule and the road, we can divide the entire transportation system into 4 categories, 4 blocks, where the time is fixed and route is fixed. This is called the transit category. This is nothing but we call it as pure transit or the mass transportation system. This is also known as mass transportation system, but it's just simple transit. Examples are the rail, rapid transit, light rail transit, the fixed route bus, the metro, and whatnot. On the other hand, if the time schedule is also variable and the route is also variable, the right-left corner, this is nothing but the zone of our private vehicle. Door-to-door service is possible. Whenever you want to go, you can start your journey. Whichever road you can go, you can take that road, no problem at all. Nobody is going to do it. It is you to decide. So, and other 2 blocks are, so one is time is fixed, but the route is variable. The van pole, the subscription bus, the car poles, etc. are the example. And whereas on the right top, where the schedule is variable, but the route is fixed. Example is Jitney. As of now, in Indian condition, whatever mode, say that Tata Max or such type of vehicle, they are providing for short travel trip like 10 kilometer, 15 kilometer, 20 kilometer between the urban area, small urban area to urban area. Those comes under this category of mobile. So all these things, all the urban modes can be categorized into this 4 category. After this understanding, let us say some other characteristics of the urban transportation mode. So as we have said in the previous diagram, this is nothing but the transit group, this is the private group, and this is nothing but the paratransit group. The paratransit, these both of them can be treated as paratransit. Paratransit is a gap filler between the transit and the private mode. So if we divide again the total urban transportation system into private, paratransit, and transit, then we can study some of their characteristics. That is the ownership. In case of private, we need to own the vehicle. But in case of paratransit and transit, no need to own the vehicle. As a parking, in case of private mode, we need the parking. Maybe in the form of garage attached with our house. But in case of transit and paratransit vehicle, we do not need to park the vehicle of our own. Door-to-door service. Say you are starting from your door and origin to destination, basically. In case of private, it is possible. In case of paratransit, if you hire the paratransit vehicle, say taxi or auto rickshaw you are hiring, then it is possible. But if you want to use the shared mode paratransit vehicle, then it is almost like the transit. Then what is the user cost that is involved? Maybe in terms of fare that we are providing or the operating cost that is being involved. In case of private, the operating cost and capital cost of the vehicle has to be owned by the owner. But in case of paratransit and transit, only we have to pay the negotiated or the predefined amount of fare. So what I am interested here is, if you want to own a vehicle, we need to own the vehicle, we have to manage the parking, but we have to put so much of amount in case of capital cost and operating cost. The only advantage we are getting is door-to-door service. On the other hand, if we are using the paratransit and transit group of vehicle, only thing is we are not getting door-to-door service, but all the things are advantageous to us. So, on the other hand, as a transportation system, if the user is using this transit or paratransit group of vehicle, the congestion reduces on the road because the absence or reduction in the private vehicle. The total amount of pollution will reduce. The total amount of noise pollution, whatever the things, everything will go down. Only thing is we need to transfer this private vehicle user to the transit user. Okay, let us now see another major component of transportation system, that is our road network. As per IRC, we have national highway, state highway, major district road, other district road, village road. In addition to the IRC classification, now we have the expressway, which were maybe the east-west corridor, the golden quadrilateral, etc., etc. And on the other hand, we have the PMGSY road for the village areas. So as of now, we can classify the road IRC 5 plus expressway or Mahasarak and the PMGSY road. The transit route we can classify depending on the service type, network type, and hierarchical type. The service type may be the fixed route, the feeder routes, the highly right network, and integrated routes. This integrated route is nothing but a combination of all the others. Normally in Indian condition, we have the integrated routes by service type. Only the feeder routes you can understand that urban area to the airport or urban area or the urban CBD to the railway station, CBD to the ISBT bus center, etc., etc. Those routes we can say as to be the feeder routes to the system of the regional transportation planning. And fixed route, as you have understood, this may be because this will depend on the transit system we are considering. Say, if you are considering bus, then the road network, a particular system of road network we can visualize. If you consider the LTR or the regional train or the say local train, then another type of railway network we can imagine. So these are the various types of road network based on the service type. Again, on the basis of network type, if you say, we can classify the road network into these categories. Out of this, the organically grown network, this is developed automatically. Normally, the unplanned urban area, whatever road network we have, those road network is nothing but the organically grown network. Any city, if you consider, the old part is normally the organically grown, but the new part is normally the planned road network. So with the organically grown road network, exactly the opposite at 180 degree to the organically road network is our grid pattern. That is the rectangular block. As an example, you can say the railway city. Any railway city, if you imagine, pure railway city. Normally, their road network is grid iron pattern in Indian condition. It is very flat. And in between, there are so many types of other road network: radial, circumferential, territorial, linear. The linear road network. That's this. We have the linear road network developed normally due to the linear nature of the city, which the city that develops near the river or the riverine-based city and the highway-based city will have the linear road network. It is very easy to manage the linear road network city, and it is very good the grid iron road network in terms of transportation system, and the most difficult is the organic one. And the radial road network and radial and ring in combined, whatever we have in Delhi. Delhi is nothing but the radial and your ring network combination. So like this, several types of road network we have, so many advantages, disadvantages we have. The best one, the best planned one is the grid pattern, and the worst plan is nothing but the organic road network. In terms of hierarchy, if you see, say, overall, if you consider, then we can say the national highway or the expressway or the Mahasarak we have. Other than this, these four other categories, nothing but the urban road network. That is called arterial road, some arterial road, collector street, and the local street. As a whole, the width of the black line is normally resembling the width of the road network that is being meant for a particular area. This arterial road of an urban area may be the national highway or the state highway itself. And the local street or the road network which is connected to our plot or the building. So where the width is very less and the speed of the vehicle is very less, the large size vehicle cannot operate in the local street, whereas in arterial road, vehicles are moving at a higher speed. The number of stoppages are very less, whereas in the local street, we can stop anywhere on the road. So, in terms of accessibility and mobility, the mobility increases in the arterial roads and the land accessibility or accessibility is more in the local roads. Then another very important component of the overall transportation system is nothing but the user, because whatever we are doing, the infrastructure, road infrastructure, or the vehicle or the transit system, whatever we are doing everything to satisfy the user. So who is this user? We have to know very carefully what is their character, what they want actually. We have to design everything as per to say or satisfy their need. So the overall user we can divide it to two major categories. One is captive rider and is choice rider. Captive rider means cling to a particular type of transportation system. And choice rider is he can use any type of transportation system as per his requirement based on his availability and the need. This captive rider we can categorize again into two categories. One is transit captive. This group of people is nothing but the economically weaker section of our society. They do not have their private vehicle. They have to use or they are bound to use the transit system that we have in our urban system. Another group is there in our urban area, that is automobile captive. That group is the higher up, economically higher up, or the ASIG or say the top class citizen of India. That is the economically higher up group. This group of people, irrespective of their need or the distance to be traveled, they will not use other mode of transportation other than their private vehicle. So this is called the automobile captive. So transit captive, the bottom class of our society in terms of economic class, and automobile captive, the top category of citizen in terms of economics. And in between is there our choice rider. You can say this is the middle income group of our society. So when they were going for say off-peak, they will use transit. But as soon as they are going for marketing, they will use a private mode or say hired taxi or hired auto rickshaw, etc. That is, this is called the choice rider. In terms of Ranmaker economic class, if we divide our entire user group, we can divide into these four categories. One is called real have-nots at the bottom of our society. This is nothing but the economically weaker section of the society, which in my previous slide, we have talked about the transit captive group. And another group is real have. They are having their own automobile. This group is nothing but the automobile captive. So these two are the captive group I have described just in our previous slide. And in between is dummy haves and dummy have-nots. This is our middle income group. These people, this group of people are the people in transition. In this diagram, we have resembled these two groups of people in transition. They will use whichever mode is better for a particular time and hour of the day. So, what for we are interested? Our basic interest is to reduce this group of people and transfer this group of people to the transit user group. Then the transportation problem will be resolved. But the problem is the automobile captive group of people we cannot transfer to the transit captive. It's not possible. They will not use it. Transit group of people is already there with us. That is the transit user. Now, most vital decision maker is this group of people, people in transit. So they are opportunistic. Whenever they will get whichever mode cheaper and advantageous, they will use that mode. So this group of people, normal tendency that dummy has, this group will try to go to transform to the real haves. That is, they will go for automobile captive group. So we have to prevent that. We have to try to use or some sorts of law, some sorts of legislation, some sort of facilities, or some sort of restrictions, so that these people in transition group, or the dummy haves and dummy have-nots, this group of people we can transfer, or we can transfer to our transit user. Then our road will be free from the private vehicle. The road, our congestion at the city level will reduce. So our interest should be the people in transition. And second interest should be what the facility we can provide to this transit captive group of users. Because we have to think about this. These are our economically weaker section of the society. We have to think for this group also. Okay, the next part I'm trying to go to traveling part. That is the demand calculations. Whatever I have said in the previous slide, the user group, etc. Finally, we have to find out that demand of this group of people, this group of people. This group of people is not so much interested to us because they will not listen to us, and they will not be using our transit group of vehicles. So our basically interest is this, to find out the travel demand or the travel behavior of this group of people. Okay, the travel demand, as you know, is not a demand like the other demand of the community. It is a derived demand. That is, the travel demand arises to satisfy other types of demand. Say, I need something to be purchased from the market, so I am going to market. So because I need something, the travel demand is arising. So we are not just making a travel for the sake of traveling. Just for the sake of traveling, we are not traveling. We are traveling, or we are making the trips to satisfy other demand. That is why it is said that the travel demand is a derived demand. So we do it in order to satisfy particular need or requirement at different location and different time of the hour. We can perceive life as a consequence of activities undertaken at different location over the urban area and over a different day of the week or day hour of the day. To perform these activities, we need to make trips. And these trips are nothing but the travel demand. So how we can go for this? Now, let us see the transportation and the land use equation. There's a small bit of background is required. So land use, what do you mean by land use? Land use is nothing but a particular area or a land of the urban area. What is the main use of that land? Say commercial area or the city hub. That is called commercial area because most of the land is used for commercial activities. Residential area, parks, playgrounds, open area, etc. Nothing but the examples of land use. When the land use changes, that is, say the agricultural land in the fringe area, the agricultural land is transforming to the residential area, or the residential area is transforming to commercial area or mixed land use area. As soon as this land use of a particular area is changing, the trips are generated. That is, the people movement increases. As soon as the people movement increases, the trips are generated. As soon as the trips are generated or the demand is increasing, we need the transportation need, that is the travel demand arises. As soon as the travel demand arises, we need to provide the transportation facility, maybe in terms of road network, maybe in terms of various types of vehicles, various types of transit systems, etc. we have to provide. As you provide the road network to meet the demand, as soon as you are providing the various types of transportation means to meet the demand, the accessibility of the land increases. As soon as the accessibility increases, the land value increases. Here we can understand this simple things. A plot in the urban area, so if the plot is attached to one side road and another plot is attached to both side road, the price of the plot which is attached to both side road is much more than the plot which is attached to the road in one side only. If you compare a plot at the back of the first plot, which is not attached to the road network at all, the land value is reduced. So this is nothing but the accessibility and the value of the land. As soon as the value of the land increases, the land use changes. Say for example, the residential area which was a single street or double street, say 20 years back, now that area has become 5-story building, 4-story building. Some of the area has converted to even commercial area, light industrial area. Then what is happening? Earlier, the residential area is being sensed to commercial area. That is, the land use is being sensed, or the intensity of the land use is sensed. That is, the area is vertically growing or horizontally growing, or the population of the area is increasing. The land use is being sensed. As soon as the land use is sensed, again the trip demand increases. Number of trip generation increases, the travel demand again increases. So this will go up in transportation system. This is a continuous process. So as soon as some problem arises in the transportation facility, and we are solving the problem by means of some temporary solution, say for example, a intersection, congestion in an intersection can be temporarily overcome by putting a flyover, but that is a very temporary solution. If you rotate around this, you will see that after 2-3 years, that flyover will be again over-congested. So it's a dynamic system, whatever I was saying earlier. So we need to understand this land use and transportation relationship very clearly to estimate the demand or the transportation need of the people. So this is the thing about the sequential demand analysis, where, as you all see, is the trip generation. First case is trip generation, The second phase of modeling is the trip distribution, mode choice, and traffic assignment. What is this? Say if the urban area is divided into several sectors or zones, say for example, our ward, the urban area as per the municipality has already divided into various zones in terms of the ward. Let us consider ward boundary as our zone, or each of the ward as one of the zone. So what is the total number of population of that zone or the ward? So that is how much trip is being generated from that word, a particular word. So that is nothing but the trip generation. This is related to the decision to travel. So that is nothing but the trip generation. How much trip is generated? And say for from a particular word, say word number 10, 100 trips are generated. Now this, if the urban area is consisting of say 20 number of words, then from the zone 10 or the word 10, from where 100 number of trip is generated, that 100 trip is going to other 20 trips, other 20 word. So how much of this 100 is going to each of those words? That is nothing but the trip distribution model. Say zone 10 to zone 20, 10 number of trips are going. Out of this 10, there are say 5 number of alternative modes. So city bus is there, then your private car is there, then bicycle is there, two-wheeler is there, so auto rickshaw is there. These 10 people who want to go from zone 10 to zone 20, how much of them are using transit? How much of them are using cycle rickshaw? How much of them are using auto rickshaw? That is nothing but the mode choice model. There's a decision to choice of model. This purely depends on the choice of the user. Then say the zone 10 to say zone 20, if you want to make this travel, there are say 3 alternative routes. Which route they are taking? That is nothing but the traffic assignment or the decision to road choice model. This is nothing but the road choice model. So with this background, let us go to the travel demand forecasting. This travel demand, again, will depend on the allocation of the urban activity. Location and allocation of the urban activity. So before going to this truth, just I want to give you a simple example. Let us consider our household itself. In our house, residential house, there are various different types of rooms. What is the activity? Various activities going on in our various rooms, say the kitchen, or the dining room, or the toilet at the section, or the bedroom, and how we are moving between room to room. If you see the room which requires maximum number of movement, those rooms we are putting together. That is the reason the kitchen and the dining room are put together. If you are ever with this, that means what? Our basic objective is to reduce the amount of travel or the quantity of travel. So urban activity, if it is decentralized, say the market is somewhere, industry is somewhere, then residence is somewhere, the park and entertainment center is somewhere, the regional transportation mode is somewhere, and they are apart, say 10 kilometer, 5 kilometer apart, then the more number of trips will be generated. The travel demand will be more. And if we can put together every activity in a single place, the demand for travel will be less. But the problem is, if you want to put all the activity of the urban area in single location, then there will be over density of the activity. The footprint will be more. That is, all the people will come to avail those facilities and will not have sufficient road network, sufficient water supply, sufficient infrastructure facility. Everything will be in scarcity. So we cannot do that. So finally, urban activity has to be well settled or well located so that neither over demand is happening or over footprint is accumulating in a single place, or the travel demand is unnecessarily increasing. We have to balance this. So because of the location, allocation of the urban activity in the urban area, the trips will be generated. And as the trip generated, it has to need to be distributed, the mode choice, whatever I have described in the previous slide. And finally, we have to provide the entire trips that is generated either on the transit network or highway. This means either we have to load the trips to the transit, or we have to request the private user to use the highway. That is nothing but the highway or transit loading. So finally, depending on this, again, the urban activity will be allocated or dislocated. Many times we find that urban activity is being dislocated. Nowadays, whatever is happening in most of the Indian cities is that most of the large size mall, etc., recent activity, those are being put in the central area of the urban center. And because of that, more and more people are coming to this large size shopping center. And the result is that congestion on the road, no parking place, pollution, etc., whatever is happening. All this problem is happening in our urban area only because of our concentration of the urban activity or centralized urban activity location. So this we need to control. We have to control the vertical growth of the city as well, because if you allow the urban activity to be more centralized, the vertical growth, that is the double-story building, will be converted to 5-story building, 5-story will be converted to 10-story building. Ultimately, it will become something like the Burj Dubai. So that should not be our consideration at all. Again, urban activity forecast, whatever I have said, initially we have to just forecast where it should be located, then the travel demand need to be assessed. Okay, finally this 4 model and how to calculate, again the base year data and the loading of the zoning and the network data. Then the first model is trip generation, which depends on the number of potential trip maker, the propensity of the trip maker, and the accessibility of the attraction zone. There are 2 types of trip generation model. There's the cross classification and regression model. Finally, I have to escape many of things because of this time constraint. Again, the distribution model, the trip distribution model, this is again depends on the number of trips generated in the origin zone and the in situ attraction activity of the destination zone and the distance between them. That the various types of trips that generated. So there are gravity model, intervening opportunity model, choice model, and entropy model for the trip distribution. This is the gravity model, one form of gravity model, which basically depends on the your AJ. This is set of attraction of the distributed zone, and the distance between them. The choice model normally we use the logit model. It may be binary or it may be the multimillion logit that we use for mode choice analysis. And finally, the traffic assignment model, which depends on basically the time, how much time it is taken to travel between the origin zone and the destination zone. These are the various models available for the traffic assignment model. Okay, I'm coming to the last slide. Here I have tried to give some idea of the research direction. So whatever you have listened from yesterday. So one of the very, important thing is automated data collection. Now the research should be in this most automated data collection. That's one of the example is, so whatever Vinod Vasudevan sir told yesterday about the instrumental vehicle. This is nothing but the sensor-based automated data collection method. Even today, Maji sir has described about your driving simulator. So such type of sensor-based data collection method we have to devise. And after collecting so huge data, where this data is to be stored, that we need to think. And that huge amount of data, which is difficult to operate, how to filter that data, which part is useful for us, and what type of analysis is to be performed with such huge amount of data. This you can say is nothing but the big data analysis. And here we need the contribution of other experts like say computer science engineer or the electronics engineer or various sensor based, etc., etc. So here we need the collaborative research, and this is the most promising zone of future research. And another very recent thing that happens because of pandemic situation, because people are afraid or say not trying to use the mass transit system or the transit system, then what they are going to do? They will use the private mode. Now, if all of us start using the private mode, that what will happen to our road system? How many additional vehicle is being loaded to our road system? Is our road system is capable to hold that additional loading of the vehicle? Or we are going to be over congested in near future. So what is going to happen? That is nothing but the mode choice analysis we may think seriously regarding this during an post-COVID scenario during mode choice analysis. So thank you very much. With this, I'm closing. Over to Ambika Madam. Thank you.
Thank you. Thank you, sir, for the presentation. So now some questions you can take from the YouTube channel in the chat box. So you can continue with that.
Yeah, just I'm open this chat box. Oh my goodness. So much of question.
So you can one question, another you can answer in the chat box.
Yeah, this is Damaji. Dhami. What could be the possible planning intervention that can handle the post-COVID?
You read out. You read out the question.
Sir.
Read out the question.
Okay, the question is, what could be the possible planning intervention that can be adopted post-COVID-19 in the field of urban transportation to make the public transport system most efficient and safe in future? Very good question and very relevant, because as I have just said, that public transportation system, if the people avoid using, then there will be overloading to our transportation system. So what we need to do, we have to basically sanitize the public transportation system frequently, and the number of users has to be reduced. That is the capacity of the transit system, overall transit system will be reduced, but we have to increase the number of fleet size. Vehicle size is to be increased, and the sitting capacity has to be reduced. That is, I am not saying that number of seats to be reduced, but there should be, say, alternative seat can be allowed for sitting. That has to be controlled from our urban transportation system operator group. Okay, then Ajay Patel has asked, best economic and accurate way to make transportation in rural areas. Yeah, even the last Professor Maji sir was describing so many things in the rural area. So need of the rural area and urban area are not the same. In terms of speed, it is different. The geometric criteria of the rural area is different. So accordingly, so we have got that rural area road design criteria, then your PMGSY road system. So accordingly, we can use what type of road is required for what type of vehicle that is encountered. So definitely, in rural areas, other than the national highway, the traffic loading or the equivalent single wheel load is not so high. So the thickness of the road system, the way we are doing in PMGSY road, is not like the national highway. We can reduce those parameters, design parameters, and we can reduce the cost etc. Yeah, just a minute. Yeah, Anha Varghese. Can we use artificial intelligence in transportation planning, urban transportation, by improving the facilities? Yes, 100%. So nowadays, whatever we are doing, artificial intelligence, as I was trying to say in my last slide, the modern tools has to be used. Otherwise, there is no excuse. When I have said the expert from computer science engineering background, the experts from electronics, electrical, this expert has to be here with us to solve the urban transportation problem. We have to do it, otherwise we cannot solve in the classical method. Nowadays we cannot solve the problem because it's a big data age of the big data. You can say. We have to see this. Thank you. I think,
Yes.
should I close? Yeah. Thank you very much.
Thank you.
Over to you.
Yes, sir. So now
Introduce.
Yes, yes, I'm there.
Introduce.
Hello. 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 Am I audible? Delivered by Dr. Ambika Kuiti. So let me just briefly introduce her. Dr. Ambika Kuiti serves as an assistant professor in the Department of Civil Engineering, NIT Silchar. She completed her postdoctoral fellow at IIT Bombay and PhD from IIT Kanpur in the area of pavement engineering. She has completed her master's from IIST Sipur. In her master's, she received a silver medal for securing first position in Masters of Engineering among PG students of Civil Engineering Department. She worked in an advanced pavement laboratory during her postdoctorate. She acted as a reviewer for 2 international journals and 2 international conferences. She has 5 SCI journal papers and 8 conference papers from her PhD and master's work. Her area of research interest is on asphalt mix characterization, the microscopic study on asphalt mix, rheological characterization of asphalt binder, reclaimed asphalt pavement material characterization, and so on. So, without any further ado, I would now request Dr. Ambika Kuiti to deliver her presentation now. The floor is all yours. Please.
Thank you, Suprabha. Am I audible?
Yes.
Yeah, you are audible.
Okay. Okay. So a very good afternoon to all of you. Before going to my topic, I would just have a kind of request to all the participants that whatever you are writing in the chat box, please be careful because we are here to hear from the expert. We have to give time to them that what they are just delivering, and all the webinar is about to that. So just we have to keep some patience to hear all. Obviously, we are here to from the experts. So just bear with us. Obviously, we will be we are running late. It's true, but still, as a participants, we should be there like this. Okay. Now coming to my topic actually. So thank you, NIT Silchar, for providing me this opportunity to share my some of my research work as an expert with the international webinar. So few words from my PhD research work I would like to share with you that how we quantify that the material, what is from the waste material we're getting generally as a filler. This is very basic topic, but still we would like to cover that area because lots of interesting things are there. Here we can see that in the road, these are made by the different, this is called the flexible pavement. This is a black top road. So here what we can see that lots of aggregates are coated with the bitumen, but we are unable to identify that what are the aggregates are present within that sample. So here, if we will go for the cut section, then we might have observed that lots of different sizes of aggregates are there, and it's composed of almost 95%, and remaining 5% are asphalt binder. If we look have that within that mix, that some portions are it not clearly visible. That portion is called that in terms of mastic. So there, if we go for the alternative, different, this is the age of the different imaging equipments we can use to explore that area, that internal structures. What we would like to say that how that internal structures are able to give you that mechanical strength, how it's are going to improve. So there, what we are observing that some portions we are not able to see by using that simple, what we are using a regular day, that camera. So that camera is not able to observe that portion. So we need some advanced equipment to observe that what is going on inside that how those particles are distributed in the mastic. So here, before going to that portion, what we'd like to say that what are the waste material? That is a burning topic nowadays. So several peoples or several researchers already explored lots of waste material into the asphalt mix. So here some of the few materials I am highlighting. So here these are the conventional materials, and whereas these are the unconventional materials. The conventional materials what generally we are used, that by using that normal weight, but by the weight proportioning scheme we may use, but that will create problem when we are going to use that as an unconventional material, because the material what we are going to use, that things are not in the same density or the specific gravity. So if you would like to say that this is the rice husk ash, so here that if you will burn that one, obviously the specific gravity or the density of that rice husk ash will be very low. But in the construction and demolition waste, that may be high, or as well as for the litter if you are going to use, that is very minimum. So here these unconventional materials we may use as a whole gradation, part of the coarse material, or maybe the part of the fine aggregates, or maybe the part of the filler. So here we are use that can I make the asphalt mix by using single sizes of aggregates? The answer is no. So that's why what we have to do, we have to use different sizes of aggregate, and if we will mix that one, it will give you a mixing. But from where we will get that adhesive bond? So therefore that we have to use the asphalt binder, and ultimately we will get this kind of product, which is very much stable and very much significant to give us the smooth ride on the road. So just before going to directly go to the filler, we would like to use the terms aggregate gradation. And what is aggregate gradation? So here, if we will see that in the different field, how the crushers are used, that how these aggregates, we have to large size of aggregates we are getting from the hills, and then there we have to crush that aggregate at different sizes of shapes. And there in the laboratory, what we are using, that we are using that shape size. Different shape sizes of shapes are present there. By using those shapes, we may use that the below 4.75 millimeter as a coarse aggregate, whereas above of the 4.75 as a coarse aggregate, whereas below that one we are going to consider as the fine aggregate. And in general, we are considering that below 75 micron is a filler. And we are getting the whole aggregate gradation, like this image, what is it is presenting like this, the cumulative percentage percent. And while we are using this type of aggregates, then different type of gradation we are getting. That someone is called a well-graded aggregate, where the all shape sizes of aggregates are there, from starting from the coarse to finest. And here the gap graded, by name itself, it suggests that certain sizes of aggregates are not present in that gap graded aggregate gradation. And another more is the uniformly graded aggregates, where only a certain shape sizes of aggregates are present. And these will give you the different mechanical properties when we are changing all these different type of aggregate gradations. So aggregate gradation has a very crucial role to play in terms of its mechanical properties, to enhance its stability, enhance its workability in those aspects. So MORTA specification, as per that specification, they define various type of gradations, and then they consider the different quantity of the filler. If we consider that below 75 micron are considered as a filler particle. So for different aggregate gradation, they specify that different aggregate gradation. So in the gradation, we may observe that the whole aggregate gradation may be in terms of the 10 to the power 4 times of aggregate size, started from the 90 millimeter to less than 75 micron. Let's say for the BC grade 2. So this is huge. We cannot capture the whole aggregate gradation through a single imaging equipment. So coming to the smaller sizes of fractions, that some portions of aggregates are in contact, some are in the suspended conditions. So here in the contact particles, so those are in contact, but how it will stay together. So some of the suspended particles which are there, so it will help to bind that aggregates together or hold in a same position. So now coming to directly to the feelers, that how it works. If we will mix that feeler with the bitumen, then it may act as a modifier, or it may be the integral component of a mastic, and obviously it will help to pack the whole voids what are created by the skeletons created by that coarse aggregate and the finer aggregate. And wherever will be the void, that may be filled by the feeler along with the asphalt binder. But here in the bituminous mix from the julcate, whatever we can observe that filler particles, which may be considered as the circular nature, so those particles can be act as the ball bearing particles. So when you will going to compact that sample, so it will orient the aggregates and it will go in the stable position. So this can be the fact that what the filler's role is. So the interesting question is there that what we considering that this is a filler. Now, is it true that below 75 micron particles passing is considered as a filler? But different or specification has given the different aspects regarding the definition. Whereas Morth and the ASTO, they have considered the below 600 micron passing, 300 micron, and also they considered 75 micron that chip sizes as should be considered for the filler definition. Whereas European code, it has considered that less than 2 millimeter, that is the huge range from the 2 millimeter to below 63 micron. So that range will come under the definition of filler. But in general, what we are considered, that is the below 75 micron passing materials. So here is the same questions I would like to say that if we are going to use the different materials, so the big issue with the density. So if we are going to use that rice husk ash, then while we are using that by using the weight proportioning scheme, that will give you the huge quantity. If you can assume that rice husk ash, if you are considering that 7% of stone dust and 7% of rice husk ash, if you will consider it, then the quantity of the rice husk ash will be huge. If you are going to mix with that thing within the standard asphalt binder content, then other components are kept fixed. Then obviously you are not going to get that exact, even you cannot prepare that sample because the rice husk ash may have that great get absorptions, more absorptions of the asphalt binder. So it will create some problem. So this is our existing approach that while that we are using by weight, when the volumes are different, then we are getting this kind of problems. That it will absorb more binder, or it will give less stability or the stiffness within the mixes, and obviously it will hinder the performance of the mechanical properties of this asphalt mixes. So the next proposed approach, what we proposed, that is the volume proportioning approach. That the same volume, what is we are getting from the stone dust, that is the conventional filler, the same volume we are replaced with the filler which has a low density and the high density. And we are prepared the samples. But obviously that is also going a different type of results based on different quantity of the filler particles. This is the volume proportioning. Then again, this question is arise: thus, which one is the best approach? Weight proportioning scheme or the volume proportioning scheme? So here, with the advantage of this imaging equipment, what is a very crucial role that internal play? It has a role to play that internal arrangements of the particles. So we can move forward for the microscopic study. Through the microscope, advanced microscope, we can look at that position, that how these filler particles, different sizes, different shapes, that different characteristics of the particles, how we can observe those things. So with the help of this one, the advanced imaging equipment, we can move forward that by microscopic study, we can explore that area, that which one we can, how we can quantify that optimum amount of the filler. So here are the basic needs that why we would like to see that microstructural studies. So through that microstructural studies, we can explore its morphology, the composition, what is there, and the orientation of the particles, what is, how they are oriented within that sample. Then if there is an interaction, if any something crystal structures is formed, then how different kind of formation is there. If there is any impurities while we are preparing that samples, so all these things will be clear under the microscope. So we would like to explore that area, that if we can get some advantage from that advanced imaging equipment. So here we have used that scanning electron microscope, and here the basic thing that how it works. That by name itself, it is suggested that we are going to use the microscope which are able to hit that electron gun and through the conventional lens and the objective lens, and it hits the specimen, and the specimen relieves some electrons. And here we can see that the detector is there. So if we will keep that detector at different positions, so it will collect different type of electrons. So based on that, we can get the raster nature of that sample, the surface nature of the sample. So that thing is coming out as a different kind of electrons. If we are hitting with the primary beam of the electrons on the surface, then if a very nanomicron, if it will penetrate, then it will refer that secondary electrons. But if it will hit something more around 1 millimeter in depth, then it will may scatter that backscattered electrons. Otherwise, it may transmit different kind of elastic. So lots of electrons through that heating of the electrons in the specimen. So lot of different type of electrons we can gather, and different detectors will be available, should be available with that instrument to to attract that electrons, and we will get that image in our as a raster image. So those image we can see that, the sample preparation, that image, considering that image, whatever is we are getting from that ACM, but sample preparation is very crucial stage. I must say that for the powder image, powder materials, what are we are going to use as a filler, if it is in the powder form, then it is not going to create any problem. So directly under the ACM, because this is high vacuum chamber, so obviously we have to keep in mind that the particle should not go with within the vacuum. It will damage the detector. So both side tape we have to put on the stud, and then we have to put the samples over that one, and we have to blow excessive materials what is there, and then only we can load that sample within the chamber. But before that, we have to remember that whatever we are using, those particles are really very non-conductive materials. So to make it conductive, we have to need a sputtering unit. There we may use the gold coating or maybe the platinum coating to make it conductive. So after this sputtering unit, where we have to keep that coating, the chamber, the pressure should be 4 to 6 Pascal. And then we have to load the sample or the coated sample here in this loading chamber. And after that, we will get this kind of images, different waste material, what we may use. That may be the brick dust, maybe the fly ash, or maybe the recycled concrete aggregate, or maybe the lime, and as well as the stone standard or the conventional filler as a stone dust. So in the conventional way, what we have a thought that filler particle is a very tiny particle, so that may be the circular in nature. But when it comes under the ACM, then it totally breaks our that knowledge. We have a thought that this should be the circular in nature, but it shows that really this is not the case. Where the stone dust is really looks like a stone, whatever we are observing as a coarse aggregate or the fine aggregate. So these are the smaller fraction of that stone. So this is similar for the brick dust also. This is the broken part of the brick. In the fly ash, obviously it is really closer to the circular one. Then the recycled one, it is mixed with the very fine and the coarser as well. The lime, obviously this is a very conglomerate structure. So how those things are, we are looking through the ACM, that this is like, we didn't expect that what we will able to see. But under ACM, we are able to see that the structures of different filler particles and the steps, everything is totally changed. So this plays a very crucial role within the mastic while we are mixing with the bitumen. So here we can see that for the filler or the powder particle, that powder particles, it is not that much tough to prepare the sample. But when it comes to prepare the sample from the asphalt mix, because we have to look that when we are mixing this filler particle within the asphalt mix, that how it behaves within the asphalt mix. That thing we have to understand. So we had to get the sample from the asphalt mix sample itself. So how we can get that sample? So the first say that this is a 2D conceptualization of the filler concentration, that these are the aggregates, larger aggregates, and we might observe that this is the river of the bitumen, and where these filler particles are embedded. It is moving within, it is floated within this binder, river binder, or this river of the bitumen, and it moves through all the voids it will fill. So here the general methods to prepare the specimen are the first we have to prepare the sample, that the Marshall sample what we have prepared. Then after that we have to cut the sample, and after that obviously cutting sample has a very rough surface, so we have to go for grinding, and after that to get the reflective nature of the surface, so we are going for the polishing stage. And after that, under that scanning electron microscope, we are observing that how these filler particles are distributed. So here is the cutting method. We are using that diamond cutter for cut the sample in smaller pieces. These samples may be, but the height should be obviously the main constraint of the ACM. While we are doing that testing, then taking the images, the height should be maintained. It should be less than 5 millimeter. And the size, while we are cutting that sample, we should maintain that height every time. And after that, we have to, cutting that sample, we have to grind into a standard size, that is 1 millimeter, that is 5 millimeter height, 5 millimeter width, and 1 millimeter of, well, that is the length. So this is a very tiny sizes of asphalt mix samples we have to prepare, because the sample loading constraint is there. So there we can use different type of abrasive. Generally we used emery powder for 80 micron sizes for grinding purpose. And this schematic diagram showing that how this materials is grinding, and it gives us the smooth surface. Here the huge rough surface after cutting, and then while we are grinding with this machine, then we are using that we are getting back that surface with the smooth surface. And after that we have to do the polishing. So against the rotating flat disc, we have to use the silicon carbide powder in the polishing clothes, and then it will give you that final, the sample will give you look like this. The size is very small, and this you have to use for the ACM images capturing. So if we will summarize that in a whole sample, then also we can use like this. But after doing the preparing all this tiny samples, but then it while we're preparing this sample, then it will damage that orientation of the particles, because this sample is very small. We will not exactly get that what we want to observe. So there we would like that if we will number of sample we may increase, while if we will increase the size of the sample. So we use the 25 core cutter and we increase size from 1 millimeter to 25 millimeter of sample. So that sample we can directly loading, instead of 8 we may load 2 samples within the ACM chamber, and there we can get that samples how we are, if that aggregates are there, then between the aggregates how those filler particles are situated. So here some images we can have a look that this is the surface of the aggregate. Is initially whatever we prepared, maybe this grinding is not clear, but it looks like that, that how clear images we are getting from that from the ACM. And here is that the images, the river bed of this bitumen filled with the filler particles. And even if we will go closer, then we may see that how these filler particles are floated within the asphalt binder. So these are the filler particles, very tiny particles, almost 4 micron. This size of these particles are floated within the river of this binder. Now coming to the analysis part, if we are getting this kind of images, then obviously we are up to this upper thresholding. We have to find out that this kind of images, and we will observe that this kind of images will give you that the area occupancy of the filler particles. What is that we are observing, those things are the fine particles or the filler particles, whatever we are considering. But now the questions may arise that if whatever we are getting, those are very irregular in nature. So how to quantify that thing? So again, that in which size range we will put that sieve sizes. So that is coming here, that how we can quantify. That let's say we assume that this is the irregular sizes of aggregate, and we must convert that into equivalent sieve sizes of aggregate. And here we are getting the area, then how we are getting that weight from the image. So we have the equivalent area, equivalent radius, and from there we can get the volume. So after getting the volume, how we can get the weight? Obviously, we know the specific gravity of the filler. So here we can get that with the multiplication of the specific gravity with the volume, we will get back the weight of the filler particles. And also the stereological principle, but it says that several 2D images, which from where we can get that area fraction, will give you the 3D images of that sample. So it will give that area fraction will be the equivalent to the volume fraction as per the stereological principle. That principle we have considered here, because due to that we cannot go for that 3D image, so we have to consider over the 2D images. So here, again, another question may arise that waste material. Obviously, we are using different type of waste material. But obviously, those waste materials have different surface charge, because anything can be from the limestone dust, can be the rhyolite dust, like this, and our conventional stone dust, which is neutral in nature. So different type of surface charge nature filler particles are there. So is there any effect of those particles on the distributions of the filler particles within the asphalt? Are they homogeneously distributed or not? That also is another question that also we have to answer. So for that, what we did, that we used larger sizes of aggregate, because we want to see that observation in the location that here A and B. This is A is the very closer to the larger sizes of aggregate. Whether if we have different type of surface charges, obviously due to surface charge, our bitumen is a negative surface charge, and if we are using different positive surface particles, and the coarser aggregate with different surface charge, then how this effect will be there. So we think that if it is then in the position of that particles may be closer to the aggregate, larger aggregate, or maybe away from that. So in these two locations, we would like to see that how these filler particles are going to distribute it. So if we're going to more closer looks, then we can find that filler particles are distributed like this. So further, we did that XRF study, X-ray fluorescent microscope, X-ray fluorescent test we did, and based on the silica content, we go for the find out that nature, that what is the exact nature of the used limestone dust and the granite dust and the rhyolite dust, whatever we considered for our study. So here we considered that granite dust is a neutral one, whereas for the positive charge is this limestone dust and the rhyolite dust is the negative charge. So those particles we are mixing with that to prepare the asphalt mix sample, while we are kept other particles as other aggregates as a limestone aggregate. So here through the visual inspection, what we can see at the position A and the position B, that all the images are looking almost same. This is the first visual inspection through which we can say that yes, these are distributed homogeneously. But this is not enough. But still, again, we have to justify that what we are looking under this ACM are these are the filler particles. So for that, we go for the hydrometer study, and then we compare whatever we are getting from the images in terms of the volume, and it shows that corresponding results are very good and well matched. So from there, we say that, yeah, these are indeed the filler particles. These are not the ripples coming from the images. So another method we have to use that what is the area coverage method to justify that whether these are actually homogeneously distributed or not. So first, at the different position for different fillers, we have find out that every area coverage. Obviously, it is observed that for limestone dust, at let's say for limestone dust, and it is always observed that for the limestone dust, granite dust, rhyolite dust, this is the different size, different area occupancy value is different. Area occupancy, how it is described that the filler particles which are present with respect to the whole image area captured through that ACM. So this area occupancy is different due to the density nature. That while that density is different, so that quantity whatever we have used, that is different. So by weight we have used here, so it shows that different quantity is there. So here in this position, whatever it shows that at irrespective of the position, that value is almost same. Then next method is the weighted centroid method. So this is a very common method to find out the homogeneity of any materials. So here also we have used that one, that how these smaller sizes of particles, tiny particles are distributed within the material. So weighted centroid methods we have used, and here we superimpose that. This is just for just observation what we did for that whole image section. And then we just superimposed those location of the whatever we are weighted centroid we are getting for different images. We just superimposed corresponding to its center. And it shows that the eccentricity value is almost very less compared to the whole image size. This is like almost 39 to 0.9 micron. So this from here we can say that these particles, whatever are distributed there, those are not distributed scatteredly. So those are in the homogeneous distribution nature, we must say. But that also we have to proved with our statistical study, that the hypothesis one, what it says that we have to search that is there any difference in the eccentricity of the overall centroid between location A and the location B for a given type of filler. That is the hypothesis one. And the hypothesis two, what does it say? That there is no difference in eccentricity of the overall centroid for one type of filler with another type of filler for a given location. That is for a particular location we are going to study. And this study also shows, this results also shows that there is not that much of difference corresponding to the position. So our null hypothesis is not rejected. So ultimately, we must say that yes, the surface charge has no effect on the distributions of the particles. So the particles, whatever we used in our limited study, that is homogeneously distributed. So after that, we just would like to find out that after homogeneously distributed, that how these filler particles are affecting their optimum strength if we are going for certain type of mechanical properties test. So here we are using different fly ash, brick dust, and conventional material as a stone dust. So different filler particles we are using here, and we kept all the things are fixed, all the components, aggregates, rather than the filler quantity. And this filler quantity we are varying from the 6% to 12% to just have a look at how these graphs are going to change. So here we can see that for different curve, different filler quantity, that it shows different optimum value. So why it is happening like that? So with the help of this imaging equipments, we can explore that area. And this shows with just say for the brick dust, if we would like to observe that if we are going to change the filler concentration, how these filler particles are distributed within the material. So whereas this is the 6% and this is the 12%. So here we can see that how we are able to increase the concentration within the filler material while it is mixed with the binder. So here also we are observing that the stone dust, that fly ash and the brick dust, interestingly we observed that at this optimum optimum filler content, whatever we are getting that not is the filler content, that is the optimum IDT value, mechanical properties, what is there at that position. If we will capture the images, it will interestingly give you that area occupancy at that same value of the filler content, different filler content, the area occupancy will be the same. So that also we have to statistically prove that the different across different type of fillers, if we are going to use that, how statistically it can say that yes, this area occupancy value is same for all the value whatever we are getting for the different type of filler. So here also we proposed one null hypothesis that for the each pair of fillers, what is the average value of that corresponding area occupancy corresponding to their respective maximum IDT values are statistically same. So here also we did our t-distribution test and we have found that yes, this is also accepted the null hypothesis. So that corresponding to the different corresponding different filler content, the area occupancy value will be almost same. So here, but it is not possible to do every time that ACM analysis. So we have to go for a standard test, that what is the very basic test for the compacted bulk density, where it may itself consider the size, the shape, and the compaction of the materials, whatever we're going to use. And based on that compacted bulk density, we can suggest the practitioner that you may use this kind of, if we have this kind of density of the filler material. So what will be that percentage of the weight of the filler while we are excluding that from the whole aggregates. So that filler content we can find out directly from the graph. Obviously, this is based on our limited study. So in this way, we can move to find out or the quantify that asphalt, that filler quantity through that microscopic study. So again, the questions may arise that is there any other way we can explore that to finding out that whole optimum quantity for while we are using different type of waste materials. So this research is very much open floor, so anyone can access that one. That any other method they can opt to find out that how we can optimize that filler content. So with these things, I would like to conclude my presentation. These are my references, and obviously, thank you for attending my session. And this is a very good session. I must say that we are hearing all from the experts. So you just listening us, that is, we are thankful to you. So I don't know if there any question or not in the chat box. That I don't know.
Okay, so thank you, Dr. Ambika Kriti. Now this floor is open for question and answer round.
So is there any question?
Yes, yes.
Yeah.
Correct.
Yeah. Okay. One question from Ashik Baladi that, dear ma'am, what is the procedure follower for hydrometer analysis? Same test apparatus that is used for soil. Yes, the same materials, the hydrometer analysis we used, whatever used for the soil. But we may use different one instead of water. We may use the kerosene because the interaction of the water with these different things is there. So we may go for the another type of liquid we may use for the hydrometer analysis. Then, ma'am, which filler materials is abundantly available for constructions of highways? That is the depends on your local area that from where you were staying. So that local materials, what is available with you, that thing you have to use for your construction, because also you have to consider that cost. Okay, what is the procedure followed? Same questions. Okay, is there any correlation between the type of filler materials and resulting air voids in the mix? Okay, you may, yes, you may conduct that thing also, because different type of materials will give you different type of air voids in the mix. That is the problem. That's why we just go for that asphalt microscopic study actually. So that thing we just want to explore through that thing SEM. So here also that we different type of filler quantity. Actually, we don't know that how to quantify that material. So that thing we have to quantify first. That how much quantity of we are going to use that waste material. What will be that quantity we should use for getting that exact results of the conventional mix, that air voids, whatever is to be kept for the 4%. So that also we have to be considered. The size of a sample is tiny and they are subjected to various cutting polishing process. The polishing will surely have some effects on the texture. Then how can we ensure the authenticity of this terminology? That's why we just what we did, we prepared initially. We have tried to prepare that tiny samples, but after that we just facing the same problem. So that's why we kept the sample size as a 25 millimeter. So it will not hamper that much of that sample, whatever, because we are concentrating only on the filler particles. So those things are within that samples and it is not affecting that much. That's why we also did that hydrometer analysis check and the hydrometer check, that whether we are exactly able to observe that the quantity indeed are the filler particles or not. So that already we did in our study. From Abhishek Mittal, for mechanical testing only IDT was done. Did you carry out other mechanical tests also? No. We only did that actually IDT test, whatever were actually available with us. You can carry also different mechanical tests, dynamic properties test, and then also you can compare. That floor is used, so you can do that one. You're most welcome to do all those tests. So you can give the input in that area actually. Is there any simulation model to describe the distributions of the fillers in the mastic? Yes, you can do that simulation. Actually, one paper is there of mine that their basic simulation we did, that how the filler particles are distributed, how their inter distance, particle distance, you can change, that how that properties is going to change with the interparticle distances vary. So that is there. So you can just go through my website and then you can find out that link. There are lots of questions. From Ashik Baladi, did you relate the performance parameter with different type of fillers? Yes, we did lots of studies that actually I am skipping all those mechanical studies here. So lots of studies means script test, dynamic test, all those things are there. So you can also explore different other tests also, fatigue test, then rating test. You can explore that area also.
Okay, so Ambika,
Yes,
Dr. Ambika, madam.
one question is left only. So I will be done then. Okay. From the Shumit Nandi. Madam, what is actually a backscattered image? Does it give better imaging than normal SEM imaging? Okay, this is a very good question. Actually, this is what we did. Actually, we have just started with the SEM imaging with the secondary imaging equipments. Images we are getting, but when we are going to analyze those image, we are not identify that image clearly because it is only give you that surface image. So while we are going to analyze, it is not going to give you that exact boundary. But the backscatter mode image, what it is giving, that it is giving some depth essence within the image. So it will help to identify that within the image very clearly. So after lots of trial and error, we have moved for that backscattered image instead of in that secondary image. Ma'am, in what way we use eco brick and male plastic brick? Okay. So if it is there, I don't know actually what is a made plastic brick. It is made by brick. Obviously, by name it is showing like this. So if it is possible to break into the pieces, then obviously you can use in the aggregate. Or if it is not like that, then obviously you can use as a filler. Obviously, the performance you have to consider that how it is hampering that performance in terms of its mechanical properties. Okay. I hope I answered all the questions. Thank you. Thank you very much for listening.
Okay, thank you, Dr. Ambika Kwiti, for your wonderful presentation. And if any participant is having any other doubt, they can mail, they can ask over email, and she will definitely help you in this. So thank you, one and all.
Thank you, Suprabha. So herewith we just come here to the end of our second session. So this is the second sessions of this MTTS. So I am on the behalf of all the coordinators would like to thank and express our profound gratitude to the experts for sparing their time on this webinar and grace the session. It feels to hear from you all. I would like to thank the participants for their willingness and involvement. I once again want to state that we are grateful to all the speakers for being with us. It has been a great pleasure. So see you tomorrow at the same time, 10 a.m. Have a good day.